All right, welcome back. We are Game 3001. That's AI for Games at George Brown, and it's in the summer 2022 semester, and it's week 13, part one of our broadcast and recording. And again, um, we always do kind of our lab sessions first, and then we kind of do our lectures second. So again, this lab we're doing remote, but I believe, if I'm not wrong, you guys are supposed to be in class next week with Philip. Yes, I'm hoping that you guys are up to date with that. And then we'll be actually together in person next week. So can anyone confirm that? You guys have a kind of any kind of notification from Philip that you guys will be in class next week? I'm just curious before we start. Okay, good. Thank you. So Abu confirmed it. Yeah. So next week again, the plan is all things being equal, that we'll get together, in live and in person, um, kind of at the school, and it'll be the second last week of class, and all that kind of stuff. And we may also get together, if I'm not wrong, on the last week of class because you guys have to do some presentations and so on. My feeling is we'll probably, for the next 2 weeks, we'll be in class together. Okay, so that's the plan. So again, I'm trying to, again, align with Philip's schedule just to make sure that you guys are optimized in terms of travel and all that kind of stuff. That's why we're doing the stuff we're doing. All right, but on this, so this week, we're going to talk about a few new things. Last week, we talked about goal-oriented behavior and rule-based systems. We also finished off Lab 7 Part 2. And this week, we're going to continue with more goal-oriented stuff. So a little bit more abstract than just straight decision making with decision trees, state machines, or behavior trees. And we're going to talk about action execution a little bit more. And then this week, what to do. Lab 7, part 1, 2, and 3. That's worth 12% of your final grade, again, is due Sunday at midnight. That's this Sunday at midnight. It's an individual submission requirement for you guys. And we've been building up part 1 and 2, and we're going to finish off part 3 today, hopefully with no hiccups. Okay, so assignment 4, just to keep our eyes on the horizon a little bit, assignment 4 is due next week. That's next Sunday at midnight with you and your partner. That's the plan. And assignment 4 will be kind of you putting everything together, from starting with assignment 3 and then branching off and making it yourself an assignment 4 based on assignment 3. That's the plan. And then assignment 5 will be the following week, and that'll be the presentation that you guys will do in lab. So during this time frame, whether we're in person or remote, the idea is that you're going to present your assignment 3 and 4 combination, your assignment 4, your final version, to the class for marks. Okay, so that's the plan for assignment 5. So again, if we're going to put this in place, we can just say that, so assignment 5 then is due week 15, just to reiterate, and that's, kind of like, and that's not, instead of on next Sunday, like it says normally on Sundays, that's like during lab time, that's when it's going to be due. So whether we're remote or whether we're in person, please make sure you plan for assignment 5. Now, here's a question for you. What if you just cannot complete assignment 4 and you want to present assignment 5? Well, remember, the requirement for assignment 5 is that assignment 4 is complete, right? So that you need to get this done. And that's why, you and your partner, whoever they are going to, hopefully get together and finish off assignment 4 as soon as possible. Notice that it says next Sunday. There's still some time to get this done. There's a lot of stuff, like I mentioned before, that you can do, without waiting for lab components. So don't wait, because all it's going to do is you're going to do crunch, and then you either may not get things done or it may not be done right. So again, plan appropriately. Assignment 4 is due next week on Sunday, and I think assignment 4, yeah, and then that'll be bad if you delay. This week we're talking about utility. Next week we're talking about tactical and strategic AI. And finally, the last week of class, there will be a lecture, and that'll be on machine learning and that'll be the last time we get together, the Thursday of that week. Okay, so a couple of weeks kind of left, and I think there's some good, interesting topics. Today with labs, what we're doing is we're going to revisit the obstacle avoidance, kind of things we're talking about with obstacle avoidance, how to avoid them. Sprites and sprite sheets, we're going to talk about that, how to, kind of incorporate a bullet. We kind of did that together in your production class a little bit. I kind of did a brief demo for some of you, but we'll do more of a formal demo and show you how to make that work without a bullet pool. Okay, so just to make it work, just to fire something, a fire and forget type of bullet without cleanup today, kind of thing. That's what we're going to be doing. We're going to build a couple of new actions, and we're going to recreate the range combat enemy decision tree just to match with the new diagram that I've been showing you guys from the last time, right? So the last time we kind of did the first diagram, and today we're going to follow a new diagram. I just want to show you that diagram that we're going to follow for today's lab. So remember that we have a couple of tree diagrams that I've showed you. One of them is the close combat enemy. The other one is this range combat enemy. And the range combat enemy, if we want to include a more complex diagram that looks like this, I kind of included this for you a couple times. Notice that health is at the top, and then either the enemy is going to a flee state, and then it's going to check if it's not. If the health is not less than 25%, then it's going to check to see if it's been hit. If it's been hit, as an example, then check to see if we have line of sight. If not, then we want to move to, wait behind cover wherever you are. If you're already behind cover, wait behind cover. If you do have a line of sight, so there's line of sight with the player, then you want to move behind cover. So this is kind of the way we want to restructure today to kind of meet something like this. Again, I had some questions that were asked, which were things like, well, what if we don't want to use decision trees? Is it too late to switch? And the answer is, no, it's not. You can switch to do whatever you like. You can still use state machines. You can still use behavior trees if you're really motivated to. But you have to have a working prototype for assignment 3 before you go into assignment 4. So even if you recreated assignment 3's requirements and started with assignment 4, it doesn't matter to me. Okay, it's up to you how you want to do it. If you want to switch things around your AI brain for assignment 4 and make it all state machines, I'm good. Okay, it's just putting it out there because there is some flexibility. Now I'm not going to be talking about that in lab. I'll be using decision trees, but it's really up to you how you structure things. So that's kind of where we are right now. Any questions before we move on to the actual technical part today? Because we got to get moving again. We got lots to cover. Okay, if there's no questions, I'll move on. So I have pulled up, just like before, I have made a copy just to go through this with your lab 7.2 that I was working on last week. I've created a new one called lab 7.3, and I'm just going to put this up on GitHub so you can follow along. And worst case scenario, you can kind of check your code with my code. So I'm going to go CD space, and I'm just going to drag and drop the section 1 kind of folder. Oops. Let's make sure that we actually add a space in there. And I'll do just a git add dot git commit -m, and I'll say added project files for lab 7 part 3. Okay, that's what it is. And I'm just going to say git push. So it's going to be pushed up to your GitHub repository. Again, remember that GitHub repository is something that you can look at always, and you can compare your code to my code, that kind of stuff, as well as if you need examples, it's completed code that's up there for you. All right, so that's this piece. Always, whenever you start a project, again, I'm starting with the last one, Lab 7 Part 2. That's what this is. I just made a copy. For you, you would be continuing with Lab 7. Hopefully, you've got one continuous copy that you've been using, or maybe you started off with Lab 7 Part 1 and created Lab 7 Part 2 last week. But I won't be sharing a Lab 7 Part 2 starter. So you have to start with lab 7.1 at the very minimum because there's some stuff you need to add and make sure that it works. So let's run this thing again. We always run it to make sure that we have a working kind of version. There we go. And kind of the first thing I want to do is I want to go into my play scene just really quickly so I know play scene.cpp. And I'm just going to go into the start method just really quick and change this to lab 7.3. So this is the lab, the last part, number one. And the second thing is, notice that our close combat enemy was the one that we're using. We're going to switch to a ranged combat enemy just from the beginning. So I'm going to comment this one out. And again, in order for me to switch to the ranged combat enemy, I need to go into the playscene.h and I need to comment out the close combat enemy and comment in the ranged combat enemy because that's the one that we're going to use, you know, for most of the things that I want to try and figure out today. Okay, so let's run this thing. And I want to do this, again, continue from last day, just because we're going to expand on some of the actions and conditions. We've got quite a few of them, and you can see what we've done is we've built up our actions and conditions, action and condition classes over a couple weeks, and we're just going to add a few more. So there you go. So there's the difference. So you can see that it says performing move to range action, and it stops. Okay, so move to range action, and then you can see that you know, there's line of sight, and as soon as this ship has line of sight with the player, it stops. Okay, so so what we want to do is, if I was to, you know, kind of move my player around, let's say if I move the my target, which is what this is, and I move them across, you know, it's kind of weird, but let's move them over here. Right, and let's move them behind the enemy. We can do that. So we can kind of say, you know, kind of across the x-axis, move them this way. When I press the F button, I want to be able to fire a bullet at the enemy, right? And if it gets hit, then I want it to change its actions that it's going to take to a move behind cover or whatever. Okay, that's what we want it to do. And so that's kind of what the enemy, the player will do. I'll press a button like the F key. It'll fire a bullet, and as soon as the bullet is fired, if it impacts with the enemy or kind of passes through them, then we should be able to trigger the move behind cover, you know, kind of thing. Any kind of damage that's been taken. And we can also, if we don't get to that part, because it takes time for us to do all these things, then maybe what we'll do is we'll produce another key, a shortcut key that allows us to kind of take damage for the enemy. And as soon as the enemy's taken damage, you know, the AI, then it will also change its. That's another way of testing. It changes its action from a move to range action to a move to cover action. All right, this is what we want. All right, so a couple of things we want people to do, but that's the first thing. The first thing we always check to see if everything is working, and you guys should have a working version of your last, you know, kind of code the way it is. As always, there's a couple things to note up online. If you look online, if you look at labs, there are a couple things to keep note of. One of them is the lab 7 report is up. So please take a look there. Those are the requirements that you'll need to submit for this Sunday at midnight. And then there's also the instructions that we're going to follow to some degree, you know, right now. So I'm just going to go to that and follow the instructions just a little bit, just to keep us on track and make sure that we're kind of going in the right direction. So let's do that. So there's the instructions. So a bunch of files have changed. One thing to note is we've changed, we're going to change the action state, the agent.h decision tree. We're going to make a bunch of changes. We're going to rework the close combat tree, as well as change the ranged combat enemy. You know, kind of we added this new file from last day, the ranged combat enemy. So we're kind of a little bit ahead of time, but we didn't add the flee action, the move to cover action, move to range action, wait behind cover action, the enemy health condition, or the enemy hit condition. All of those things are are things that we want to add in. So conditions and actions are where I'm going to start, because this will provide a framework for us in order for us to get moving. So that's where I'm going to go first, because without these things, then it's not going to work out quite the same. All right, so that's the first thing, and I'm gonna come back to this in a second. So a bunch of stuff that we're gonna do. So first we're gonna start with the flee action.h and .cpp, and we're gonna go from there. So that means we're gonna add a bunch more actions. Let's do that together. All right, so if we go to our decisions, and notice what we've been doing. We've been adding in, kind of as many actions as we can. And remember, this is kind of following with the requirements of your assignment 4. That's what we're trying to help out with here when we do these labs, right? So if we look at assignment 4's requirements, here's the outline that we shared with you online, right? Then it's simply just looking through it and going through the stuff. So here we have AI actions. We've got patrol, we've got move to player at this point, right? We've got an attack action. So let's just flip back and forth here to the project. So here you can see, here's your attack. There's a patrol, move to player, right? A patrol action. We've got the close combat attack or an attack action, depending on the type, whether you're a close combat enemy or a ranged enemy. You can just still call it attack. We don't have the flee action in here. We don't have. We have the move to line of sight. We have the move to range. We don't have the move behind cover. We don't have the wait behind cover. So those are the ones we're going to add in order for us to build up our enemy. Okay. Now, guys, just to notice, whenever you look at some of these actions, if you're building them up for assignment 4, right? Here, look at the flee action. Move away from the player, avoiding obstacles, and leave the scene. Play the move animation. So there's got to be an animation. We just haven't been adding them in, and some related sound effects. So this is where people have been losing marks for assignment 3. I've been looking at assignment 3s, and they just don't have a lot of this kind of stuff. When we say things like play this animation, and there's no animation, just lose marks. That's all it is. Okay, so that's how it kind of works. So let's build those up. So the first thing is, let's build up these new actions. Just as always, what I like to do is do it in the operating system. I think it's just much easier instead of me building them from scratch. So I'm just going to go into lab 3 and I'm going to go into source. And what I want to do in here is start building up those actions. And let's base it on something that's already there that we know works, which is the patrol action. We know that that works pretty good. And so let's add the first action. So control C, control V, and we're going to add a new action, and we're going to call this the flee action. So flee action.cpp. And again, patrol, right? And the flee action.h, flee action.h. So that's the one we want to add in. Let's make sure I cover all of them. So I want to make sure that I don't miss anything. So that's flee action. Move to cover, move to range. So move to range we kind of already have. And remember, there's the move to range action we did last week. So I was kind of a little bit ahead of what we're supposed to do. Move to cover we don't have. So let's put that in too. So I'm just going to go back here and I'm going to grab the flee action this time and copy and paste. And we're going to say move to cover action. Move to cover, right? Action. And again, I'm just going to go back to that extra copy and move to cover action.h. So those so far 2 new ones. What else? We also have the wait behind cover and the enemy health condition. That's a condition. Let's just get this wait behind cover action going first. So wait behind cover, that's a new one. So move to cover, and again, copy and paste, move or wait behind cover. So wait behind cover action. behind cover action. And let's just add those actions in and fix them up, and then we'll go and do the other stuff for the conditions, because we don't want to lose track of what we've got here, right? So we want to add those things in here first. So far we've got them. Let's go to actions, and we'll go to add existing items. And sorry, Fabian says because agent is derived from display object class, and that class does not have the functionality to build animations, I recommend to change the agent derived from the sprite class. Oh yeah, we're going to do that for sure. But remember, that's for, you're talking about for your assignments. I agree. You can certainly do that. And remember, you can create a cascade of kind of an inheritance chain, if you will, of the right type of the class that you want to use, right? So right now, I'll go over that in a second for you, but yes, absolutely. And we'll do the same thing for our bullet that we're going to create. Okay, so let's take a look here. So we want to add in those actions. So again, we want to add the flee action, the move to cover, and move to range action. Sorry, I just want to keep track of that before I forget, and then we're going to go back and forth here. So let's look in the right lab. How about that? So there is the flee action, move to cover, and wait behind cover action. Those are the two, or the three we've added in right now. Those are the three, add them in. And then you see we have new actions that we just added in. Let's fix them. So we need to do the same fixing that we did before. So we're going to go up here, and we're going to rename this to, oops. Oh, my buttons are so awesome. So instead of patrol action, in this particular case, it's going to be the flee action. There's the flee action, and we'll replace all. Okay. So that's the same as all the other ones where we still have an action. This will be obviously called this obviously is going to be called the flee action here. So just rename this to flee, please. Otherwise, it'll cause a clash with the patrol action that's currently there. So it'll go like, which one do you want? They're both patrol actions, right? Save. And then the same thing goes with the flee action.cpp. Flee action CPP is the same thing. So we'll just Control F, change patrol action to flee action, replace all. Okay. And once we've done that, again, notice it says performing whatever the action name is. This will just say flee action. And we want to get agent, and where it says patrol, we want to say flee. Okay. Well, guess what? We don't have a flee action in order for us to do that. So let's go to definition for our agent. Go to definition. And you see get agent is from the action node class. That's what it is, right? And we want to go to the agent class, go to definition. We're just going to jump around a little bit. And down here, you can see that we have some actions: attack, move to line of sight, move to player, move to range, and patrol. But let's add some new actions. So we'll say new for lab 7 part 3. So this is again inside the agent.h because we need some more virtual functions to help us out. So in the agent.h, what we want to do is support all the new actions that we're going to add in. So we're just going to copy paste one of these and just rename it to flee. So there is flee. There's the flee action we're going to keep in. And while we're at it, we know we're going to also add in the wait behind cover and move to cover, right? So here is the move to cover action. And then finally, the wait behind cover action. These are all the new action functions, right? Wait behind cover that are virtual. We're going to override these potentially. We may override them. If they're pure virtual, then we must override. But if they're just virtual, then we may override. There's a difference between must and may. May means it's optional. Must means we have to, and we're not going to make it so that we have to. All right, so that's the That's the agent. We're going to come back to the agent because we're going to modify it to also keep track of health. But on what was just said, we had a public, our agent was a public navigation object. If we wanted to add animations to our agent, then sprite is what we'd have to add in. All right, just to go with what the, kind of the comment was in the chat. If we wanted all agents to have animation, okay, just to put it out there. Well, if that's true, and if I go back to core and if I look at sprite, what does sprite give us? Sprite is just a regular display object. So we can't just make the agent a display object unless sprites are also navigation objects. And we can look at here, navigation object.h is a display object, right? So it's almost like if navigation objects weren't just display objects, but were sprites, then so too would agents be. Okay, so that is an option. So instead of keeping public display object up here, we could change our navigation object to a sprite, and that's something that that would satisfy, what you're kind of saying there, Fabian. All right, that's one way of doing that and you'd want to do this because the navigation objects, all navigation objects would be sprites. That means it'll give you more capability for everything else. Now, if you wanted to keep it lightweight and you said only agents, right, as an example, and it wasn't just navigation objects, but only agents, then yeah, that would be a problem because you need the navigation object functionality, which is the ability for you to have get grid and set grid positions, maybe in the future, right, as an example. And that's why we make them navigation objects. So again, in this case, we're not really using get grid and set grid because we're not really using a grid system. But just to put it out there, if you wanted to do pathfinding or something, then they would have to be navigation. So it's really up to you how you want to do it. Here, I'm not going to make a change right now. I'm just going to keep trudging along. But if you really wanted to, then yeah, you just change this from navigation object to sprite. And if you just did that, and what we would do is, of course, we would just comment out this navigation object.h. And then if I go back to my flee action now is complete, right? So things would most likely still work. Okay, so it's totally something you can do. You can always change your agent to a sprite because we're not using navigation object. But if you were, then the right thing to do is navigation object to change to a sprite. So that way all navigation objects can still have this extra functionality that we've positioned here with the grid position and all that stuff, okay? Totally up to you how you want to do that though. All right, so going back to agent.h, let's just switch this back to navigation objects, just so we're not making that change right now. And I'm going to go back to my flee action. So here's my flee action, and my flee action seems to be complete. Okay, so everything else for my flee action is working now, and that's good. So save, and that's all beautiful. Let's move on to the next one. Flee action's done. And let's go into the other ones that we've just added in, which are the move to cover action. So move to cover action, here it is right here. Again, what we want to do is we want to control F, change the patrol action to move to cover action, move to cover. And sure, let's make sure it says the right thing. Move to cover action, awesome. So that's changed. And then this will be the move to cover action up here, move, and then to, usually I do one of these because I want to keep, all the spaces are just underscores, and that should be okay. There we go, move to cover is done. And then what we want to do with the move to cover action is we want to switch up the .cpp so that it looks right too. So let's go back over here and we'll control F and we'll change it to move to cover action, realign everything, and this should say move to cover action is what this is going to say. And our agent will actually play the move to cover action now, which is something that we can do because we modified agent in order for us to be able to do that kind of thing. Okay, that's how this works. Save. In this particular case, the way we've implemented it, our implementation is what it is. All right, so that is one. And then the next one, or the last one, would be the wait behind cover action. Let's just get that one done. And just like before, Control F, we rename this to wait behind cover, wait behind cover action, right? Yep, we do. Absolutely. Well, I'm just going one at a time, but yes, you get, thank you for that. Wait behind cover, and that's been changed. We need to change this. Wait behind cover, wait behind cover action. So we need to change these ones. People ask this question, like, why do we always have to change these ones up here? Who cares what these things say anyway? Well, it's super important because if you don't change those, then your code won't run. Make sure when you make new classes that these up here change as well to reflect the name of the class. Otherwise, you'll have issues. Okay, so that's something that we have to do. These are guard functions that prevent you from double including a an interface like this. Okay, there we go. Control F, and again, we want to change to wait behind cover action, replace all, which changes everything, and we want to change this to wait behind cover action. All right, and this will be wait behind cover. There we go. So that is pretty much all the stuff we did. Oh, one thing we need to do is these ones, like Yigit just said, we're not really checking for the states. So action states all have to be changed as well. So let's go to definition for those and add those new states to the enumeration. Otherwise, bad things will happen and it won't work properly. So again, move to cover, move to cover. Patrol, we have a flee. We'll put it in order, just like in alphabetical, approximately, flee. So flee, move to cover, move to range, and then wait behind cover will be the last one, wait behind cover. So there we go. So those are all the actions that we want. So save, there we go. And then let's update those things we didn't quite finish. So this should be a wait behind cover. That's something we need to do, save. And then let's update those other ones because those are also incorrect. So the flee action, CPP, this should be flee, and so should this, right? That's when flee is activated, right? And the same thing goes to move to cover action, CPP, should be a move to cover action, there we go. And that should also be the move to cover action there. These should all be reflecting what is happening. So again, always do a check if you're not sure, just to make sure that they're okay. So the attack action says attack, right? Just to show you. The flee action now says flee. The move to cover action says move to cover. Move to line of sight, move to line of sight. And then all of these, should be exactly what they should be. Move to range, look at that. Move to range says move to players. That's a bug that we never took care of. Let's do move to range, Otherwise, it just won't show the move to range action no matter what we do because we're not checking for it. That was a bug from last day. Found that one. Patrol, there we go. And then finally, wait behind cover. Those are all the important pieces. And I think now we've kind of added in the new actions. I'm just going to close all these down, close all, just because we don't need them all. And now that we've had that, just to test to see there's nothing broken, let's just play. And if nothing's broken, then we should still be able to go and we can put this up on GitHub. So you'll have all the new actions that we just added in. Again, a bit of copy pasting and some additional things, but it basically added more capability to our project because now we've got new actions we can get in there. And then we'll add the conditions and then we'll build up new kind of a new decision tree for the ranged combat enemy because the ranged combat enemy wasn't exactly doing what it was supposed to do. So far it's all good, it works, And you can see move to range action is playing nicely. Excellent. Awesome. Let's put this up on GitHub. So again, I'm just going to use you can use your own GitHub desktop. I'm going to use command line git add dot git commit -m, and we'll say added new action states, right? Which is what we did. So we did all those, git push, and we'll push those up. Excellent. Nice. All right. So those are awesome. This is good. And let's just make sure we save all. To all that, did we not change the enumeration? Let's make sure the enumeration is changed. Action states. Yep. I didn't see that in the list. Okay, so that is the first part. Next, let's do the next part, which is the other files, which are going to be we've done all the action files. We need to do the enemy health condition because we're going to keep track of that. We're also going to keep the enemy hit condition, hit and health. Player detected condition is going to be the radius condition. That's what that is going to be, right? So those are the things that we're going to have in here. Those are the new ones. So let's add those ones: enemy health, enemy hit, and player detected. So because those are conditions, again, I'm going to go into my source files here. And instead of me having to do it by hand, I'm just going to pick a condition that we know works. So if I look at here, decision, I'm just going to go here to conditions, and you can see we have radius condition, we have kind of a bunch of other things here, and I'm just going to use the radius condition as a base, and the radius condition looks like this, where the radius condition also keeps track of what if I'm within radius, and that kind of stuff is going to happen, and this can help us with other kind of conditions as well. All right, so that's what I'm going to use as a base. I'm just going to close this off for now, and I'm just going to go into this and grab my radius condition and do a copy paste. So radius condition, again, the first one is going to be, let's say, player detected condition or enemy health condition, doesn't really matter. Let's just make them. So enemy health condition, right? And this will be the same one for radius, enemy health condition, enemy health condition .h. All right, so those are the two we made, followed by the enemy hit condition. So let's, because they're so close, we'll copy this and we'll say enemy hit condition here, and enemy hit condition .h. See, that's a problem. What happens when you double click when you don't want to? Enemy hit condition .h. There we go. So we got those two. And then now the last one, which is the player detected condition. Okay, so player detected condition. And again, just to look at a condition that we like to use, our radius condition is pretty close to there. So let's just copy paste those. Radius condition, and we'll say player detected condition. Player detected condition. And player detected condition .h. And then we'll modify those. So a bit of prep. Excellent. Now that we have those files, let's add them into our conditions. So right click, we'll add in an existing item. And so let's keep track of what those are. We have enemy health and enemy hit. So we're going to grab all those, plus our player detected, which is down here. Player detected condition, those ones. And add. And now we have new conditions we have to monkey around with to make sure that they work okay. And let's start off with the player detected condition. And think about what that might look like. So player detected condition, again, I want to control F, just double click and control F. And we're looking for player detected condition. There it is. Player detected condition is what we want to change. But I hate when that happens, Visual Studio. So this is all good, right? This should also be changed. So player detected condition. A bit of copy pasting and configuration. You guys can go faster than me, I'm sure, at this point, because you know what I'm going to probably do. But let's talk about this. These usually are a little bit unique now, right? So bool, instead of within radius, we can say detected, right? So detected will be false, right, by default. Here, instead of is within radius, is m underscore, we can say detected or is detected. It's up to you how you want to do that. Set is within radius, and we only have a setter, but we don't have a getter. It'd be nice to see if the player is detected or not. So we'll make a getter. So we'll say get detected, right? That'll return if I'm detected or not. And it'll return a Boolean. So this is new. And then also a void set detected, where we're going to pass in a Boolean for detected. So there's going to be some differences here than what we had before. Some things we won't be able to reuse, but it is what it is. I think I used the lowercase l. That's why it's complaining here for this one. And that's fine. There we go. That'll make it complain less. All right, good. So that is your player detected condition. Let's leave that one up and double click on the player detected condition.cpp. Well, now we have some issues, right? So again, control F. We want to change this to player detected condition. We want to confirm all these things, but well, there's new things we have to take care of that we didn't have before. So name is, player detected condition. Player detected condition. Player detected condition takes a detected detected Boolean. Is it detected or not? And instead of set is within radius, we're going to set detected, where we pass in the detected or not. That's how that's going to function. Set detected is this. So this is set detected, where we pass in the state. Is it detected or not? And here what we said was it's going to be called detected. Typically it's the state, but that's fine. And then we can say that that is detected. And instead of within radius is detected. That takes care of the setter. And again, this will be the detected down here for the condition, but also we also want to have the getter, which is something we don't have. Let's just code the getter by hand. That's new. Where we want to say bool, and then the player detected condition, and then get detected, right? So that's what that is. So it wasn't too bad to code it by hand. I know normally we do, kind of do the declarations by definitions, or definitions by declarations, the other way around. Oh, here it's pretty easy, m underscore detected, where we're going to return that as well. All right, so that's kind of how this is. It's giving us a thing that says, hey, maybe you want to make this function const. I'm okay with that. That's going to just return whether we're detected or not. And this little underline here, it tells us other things. It says insert this for prototype member initialization. I'm okay with declaring that way. All that's going to do here is it's going to initialize the member over here altogether. Boolean, how come it says this? It says do a no discard. I'm okay with doing no discard here. And that means that these change, and it says, hey, add an override specifier for the virtual, player condition. That could mess us up. So I'm just gonna leave it as virtual. which will make it a little easier. Okay, so that's kind of how it works out. You can decide what to keep and what to not keep, right? Whenever you do these kind of replacements. Okay, so that is your player detected condition. So first, the only difference is from what we normally have is a get detected and set detected. We also have a detected, and these curly braces, all they do is initialize. Okay, so that's what they do. And that's good. And I'm just following ReSharper for this. So I'm just going to close this off for now. And let's go to the next one. So that's player detected. And then we have enemy health condition, enemy hit condition. I'd like to kind of hit those ones right now. Let's start with the enemy hit condition and talk about those. So enemy hit condition, again, Control F. And this should be enemy hit condition. So let's rename this enemy hit condition, right? And we'll replace all. Obviously, this will be called enemy hit condition, enemy hit condition. And there we go here. So there's that all done. Enemy hit condition. So again, we have the enemy hit condition. Are we hit or not? Right? By default, it's false. For getters and setters, set is hit. So set is hit. And it'll be whether we're hit or not. And this will be M underscore is hit. People made some comments about this one, but hey, don't worry about it. I'm not going to get mad. All right, so that is hit, and there we go. There, that's pretty funny. And then finally, we want to do the same thing with the. Notice I didn't put a getter here because this is kind of following along. Our player detected condition is a little different. Player detected condition is something that we can set and get, but here all we can do is set, and we're going to use the condition to get. Okay, it's just the other one we just added a little bit of a convenience function, so we can get if the player is detected or not. All right, so that is this piece. Let's also do the enemy hit condition on the other side. Control F, enemy hit condition, replace all. And just like we did before, we just have to change some of these things to make sense. So this will be hit. This will be enemy hit condition. Enemy hit condition is what it says. And this will be set is hit. Set is hit. And that is going to be the hit, if we got hit or not. There we go. And this will be set is hit, right? Where we take the, if we're hit or not, we can set up M underscore is hit to whether we're hit or not. Again, lots of the same stuff, more than anything else. One comment that I have to also make is when it comes to this kind of stuff, I just kind of comment this. Some people will make very generic, like super generic functions for some of this, okay? So what I mean is, like, instead of having all these customized names for field variables, they don't really care because it's going to return the Boolean true or false. So we don't really need to change this. This could be, I don't know, M underscore state, and then state's the same for every single one because we don't care. And then this can be actually incorporated into a condition, something like a condition superclass. So remember that if I go back to the enemy condition enemy hit condition, it comes from condition node, right? So if I go to definition for condition node does not have any private data members, but there's nothing wrong with adding in a data member that will be accessed. And you can, instead of making it private, you can make it protected. So that is another way of doing it. Instead of having to make all these names, custom names for all this stuff, like for example, hit, right? You don't need to know that. You just need to kind of keep track of state. Is it true or false? Because that's what all these condition nodes do anyway, right? So it's definitely another way of coding it. And I'm just putting it out there because people have mentioned it. Hey, what if we did it like this? Yes, it's okay, right? Okay. Let's do the next one, which is radius the enemy health condition. Okay, so again, right click double click, Control F. And then instead of radius condition, we're going to call it the enemy health condition. So when the health drops, this is for the health dropping below a certain value, enemy health condition, right? And we want to replace all those. Okay. And again, the enemy health condition is, for the most part, the same, but there might be some challenges. So enemy health condition, enemy health condition. There we go. Again, I'm just keeping all this up to date with all that stuff. Enemy health condition, enemy health condition. This isn't with within radius. Let's just call this, are we healthy? And instead of it being false, well, by default, it's true, right? This is a difference between the enemy health condition and some of the other ones, right? This could be something like set health, right? Where, whether we're healthy or not, right? And condition's the same. And this would be healthy. Okay, so is healthy or healthy is fine, right? So this is kind of where we start off with this one. And again, you can see that there are some changes starting with this. This is the change we made because we want to set the default whether the enemy is healthy or not to true. Okay, good. Excellent. Let's go to the next one, which is the enemy health condition CPP. So here it is. On the CPP side, again, we want to take a look at this. And again, instead of radius condition, this is the enemy health condition. This shouldn't say radius condition. This should look at the enemy health condition, replace all. Let's do that. And now this will be healthy, just to keep track of the same thing. Set health, right? Which will pass in healthy or not, right? And this is set health, where we're going to pass in, are they healthy? And then this will be healthy here, followed by m underscore healthy. This is kind of a, it should be lowercase. Here we go. And that should just be everything we have. Again, just lots of copy pasting, but we're just setting things up so that way we can have more functionality when we build up our new decision tree or we modify the decision tree that's out there. All right, so we've added all those conditions. And again, whenever we add something or change something, we always want to check to see if things are running. And if things are still running, chances are there's no clash, which is what we want to make sure. No clash means we're good to go and continue. There we go. So far, so good. Things are working as they should. All right, so that is this. Let's put this up on GitHub. So again, going to GitHub. Did I close GitHub? I probably did. My command line. Well, that's not a big deal. So I can just go to here and cd space git add dot git commit minus m, and we'll say added condition, more conditions, git push. There we go. Awesome. So that was the new stuff we just added in, and we have conditions and actions and all that kind of stuff. So going back to our plan, things have changed. We've added in all of this, move to range, enemy health condition, player tech condition, all this stuff. Range combat condition, as an example, do we have that? I think we have that already. Let's make sure we do, because there it is. There's our range combat condition. Again, always look, to make sure that it's right, but that's our range combat condition. So that's something we added in from last day that we did pretty good. So those are all the new things we added in. Range combat enemy.h, we already have. Action state got changed. We're going to modify our agent and decision tree and a bunch of other stuff here. We added some stuff to the agent already, but I'm also going to add in some additional things to the agent to make it more capable. Let's do that next. So agent.h is what we want to do next. So again, let's go into our core, and this is all prep again, agent.h, here it is. And with agent.h, we already made some changes, right? And some of the changes that we made were here, where we added in some of these new actions, the new action types that we want to put in. And at the top, you can see we've made several changes over the last little while. And so we're going to continue to add more things. I want to keep track of health for all of my agents, right? Because this way we can have that health condition actually work, right? So otherwise there is no health. So we get an action state, but it'd be nice if we had a health number. So we can say, I want an integer that is called get health. Okay, that's what I want. And we'll say this is new for lab 7 part 2. There it is also. So we had that part 2, part 3. Because we did this one for part 3, but I wanted to make sure we have this getter up here as well. And you know, from a setter perspective, we also want to be able to we can get health. We can actually set health. Let's just put them together. It doesn't really matter. So instead of, there's going to be a few more. One of them is going to be set health, or we can set the health value, whatever the health value is going to be. And the other one is if we had something like a take damage. Let's say take damage. And take damage is going to be something where we have a damage value that gets subtracted from health. So set health actually switches the health up. We can reset this way. Okay, if I want to reset health to a number, whatever it's going to be, or set it higher. Let's say you pick up something, a pickup will make you pick up more value. That's set health. Take health, that's like if I'm going to take damage, actually reduces the health. It would be a little calculation to change the health to something else. Okay, so that's what these 3 little functions do. But in order for us to facilitate this, we need some kind of field to hold the health value. So again, we'll say new for lab 7 part 3. We want a integer that is called health, right? And we'll set it to 100 by default. We can also do this in the constructor function. It's really up to you. Okay, so that's kind of our prep for what we're doing here for our agent. And here what I want to do is just at the top, I want to use that generate definitions by declarations quick shortcut. You can see I don't want to take care of the draw, update, and clean, but I do want to do the get health, set health, and take health functions. Let's do that. So that's going to set those function headers up, which is what we want to do. And those function headers are now stubs that we need to fill in, you know, with the stuff that we're doing. All right, so get health. Let's think about this. Get health is pretty simple, right? So we're going to return m_health. Nice and easy. And whenever we do this kind of stuff, it may recommend returning const. Sure. Set health, same thing. It'll be the other way around. m_health is equal to whatever the value is. Well, we can make that const, right? Because that's something that's not going to change. Awesome. Take health is something we're going to do slightly differently, where we're going to say m_health minus equals to whatever the value that we're passing in. So that's going to be something we can affect it. And here again, we're just going to make it const. So those are the 3 functions we've just updated. Okay, and so far so good. You know, we have our all those little functions, and that'll help us with some of the functionality we want to implement today. Okay, let's put this up on GitHub because we just modified the agent.h. Let's do that. So again, here on GitHub, git add dot, git commit -m, and we'll say updated agent.h .cpp with health functions. Git push. There we go. So that's all that done. So the health stuff got added in there because I think it's important that we have that in there as well. Okay, so that is agent.h. Let's keep going. for the decision tree. Okay, so decision tree is something we're going to modify. And first of all, before we move on, are you guys still good in terms of everything that's happened so far? Because I want to make sure that you guys are on track with the stuff that we're doing. So you're good, Vander. Okay, thank you, Ali. Excellent, Ali. That's good. How about everyone else? Maybe the rest of you are watching. That's okay. Thanks, Fabian. Let's move on just to keep motion going so we can finish this off today. So why would we need to have, before we move on to the changes, why do I need to change decision tree.h and .cpp? Here's something I got to ask you guys. Why would I need to change it? Well, let's take a look at it first, and you tell me what needs to change. So if I look at decision tree.h, take a look here. All right, so this is what we looked at last time, right? So what do we need to do this time? We've just added in a bunch of things, and we need to make changes to decision tree, or else we won't be able to use those things. What do we need to change? I know this is a silly question, but I want you to see, hopefully you can connect the dots here. All right, yes, you're absolutely correct. Add new conditions, right? Because if we don't do that, then we can't build a tree that's different. Then we can't add those conditions won't exist. And when we do that, we're going to see more conditions being kind of updated. So again, here we'll say new for lab 7 part 3, right? Then what we want to do is we want an enemy health condition pointer. Let's just say we'll start with that one, and we'll just add that. We'll include that one, enemy health condition. We're going to say get enemy health condition, or get enemy health node. We'll call it get enemy health node because that's how we've been doing it the entire time. And when we do a get enemy health node, what we're going to do, we're going to return const. So that's kind of something that we're going to do as well. So that's our getter. And realistically, because we're getting those things, and this is in the getter area, we probably want to put this, let's just put this up here for now. Just so that way we know it's kind of closer to the getters because it's a get enemy health condition. We also want to enemy hit condition pointer, and we'll say get enemy hit node. Okay, and again, we want to include the new one that we just made. That's why we needed to do all those things first. And then we want to have the player detected condition where we want to get player detected node. Okay, and that again, we need that one. Okay, so that is the getters. And well, we also have to set them. So that's something we also have to do. So that's on the getter side. Awesome. But on the setter side, we're also going to have more stuff to do just in brief, right? So again, it's going to be a void set enemy health node, which is the enemy health condition pointer node, and void set enemy hit node, which is enemy hit condition pointer node. These are the same ways we're going to keep track of everything. And then void set player detected node, where the player detected condition is going to be added in. There we go. So that is the getters and setters for the new conditions that we've just created. Okay, we made the new actions last time, so that was something that we kind of put together in .h, and the decision tree has all of our conditions, which makes sense. That's the delineation between conditions and actions. Okay, here we have to make some changes too, right? So we added some fields for lab 7 part 2. We need to add some fields for lab 7 part 3. So again, new for lab 7 part 3. we need the enemy health condition m underscore enemy health node, and looks like it wants us to do one of these because it's been initializing. And then we also want to have the enemy hit condition pointer m underscore enemy hit node. Oops. We'll just initialize. So the curly brace is just initialized. That's what we're going to do, right? So that way we're in line with everything. And then the player detected condition is m underscore player detected node, right? And again, we just want to do, we just want to, kind of initialize this way, okay? So that gives us all of the requirements that we need for the .cpp. So .h is done, but .cpp has to be updated. Let's just save everything. Make sure everything's saved, guys. And I'm just going to go to the .cpp now. But before we get there, we can get there by here by going to generate definitions by declarations, which is going to give us a bit of a pop-up. And I think this is just easier than doing it by hand. Let's finish those. And that'll give us these stubs that we can fix in a second. So yeah. So how do we put these together? Get enemy health node, set enemy health node, all those kind of things that we did before. Well, it's pretty simple. It's just going to return m underscore enemy health node. Can't pick that up. Return m underscore enemy hit node. Return m underscore player detected node. Okay, those are all the things that we want to start with. And for our setters, similarly, it's just whatever the node is. So we're just kind of creating that functionality. M underscore enemy health node, right, is equal to node, and M underscore enemy hit node is equal to node. And finally, M underscore player detected node is equal to node. So those are the ones that we've done, and I think that covers all the conditions that we're going to keep track of with the new decision tree that we're going to expand. All right, so that kind of modifies, I think, pretty much everything we need to do with our decision tree. So now that we've modified those things, let's put this up on GitHub. So again, we're just going to go here and just go git git commit -m. We'll say modified decision tree. Okay, to include conditions. There we go. Git push. All right, so that takes care of that stuff. And let's test it to make sure that things are okay and nothing's broken. And I'm testing it a bit at a time, like slowly, guys, because I don't know, I add something in, something breaks. We don't want that to happen. And so since we just made some major changes to our project because we've added in, modify the decision tree. Without a decision tree, then the AI can't make a decision. We want to make sure that we can track that everything still works as normal, and it should. I don't think there's anything we've changed that's catastrophic, but it's always good to change that or check that to make sure things are good. So there we go. So move to range. That's all good to go. All right, so that's good. So we've made changes to the decision tree, and let's take a look at our thing. So decision tree is done. Hey, okay. So there's some other things going on here. These are modifies, and we just did all these already because move to range action and all that stuff. But just to talk about them, all we're doing is we want to make sure that all the actions that we've added in are kind of coded along the same as patrol action, and that each action is going to check or kind of trigger that particular action state that we've kind of had in the player, that we keep track of in the player. All right, so all of this is pretty much done at this point. We need to think about our, we're going to get back to the close combat enemy. And the line of sight condition is something that is looking like it's going to change. So notice like it says there's a bunch of things we need to do, and just follow along here because there's a lot of stuff we could have put in the notes and I didn't because there's just so many changes. So let's think about that line of sight condition right now. Okay, so the line of sight condition, let's go back to that and let's just review what the line of sight condition does. So line of sight condition right now, when we look at it, it is a condition node, right? And we have the ability for us to set the line of sight condition as well as return that data, right? Has line of sight. But notice that the line of sight condition, it says now has agent. Well, the thing with it is that we got to think about how this line of sight condition works, right? Line of sight condition is going to be something that we can do with our agent, and that's kind of what we've got going on right now. For the most part, I don't think there's any changes that we need to make with this one, because here is our line of sight condition. We can use the setter here, and the only difference is the condition. So the condition itself, because our agent, maybe we want our agent to have line of sight instead of the condition being tracked. When I trigger the line of sight condition in the agent, then the agent gets that updated. Okay, so instead of us doing it here and individually keeping track of a field has line of sight, instead of doing it this way, maybe we can work it so that the agent keeps track of line of sight for us, is what I'm saying. So let's go back to our agent just for a second. And when we look at our agent itself, so that's the core, right? At the bottom, and I'm just gonna, put it in here. Let's take a look here. So right now already we have a has line of sight, right? We have this. And since the agent has line of sight, right? The agent here has line of sight. And we can see that there is a set has line of sight. And there's two different ways we can set line of sight for the agent. And we can also, we want to be able to check line of sight, which has line of sight, which is also part of the agent. There's not much we need to do in terms of what the agent is doing, right? But instead of keeping track of our line of sight condition here locally in our condition node, what if when we use the condition to track if the condition was working or not, and this is going to break our code. I'm just going to tell you right away, right? This change that we're going to make. But imagine if instead of trying to set has line of sight here, we just set the node, the line of sight in the agent, and then the node picks up whether there's line of sight or not. So this is going to emit some changes, okay, as an example. But this is also going to make it more flexible so that line of sight is something that all the things can have now, right? So, certainly we can keep it this way. Okay, I'm just putting it out there. There's nothing that's going to break if we don't do it this way. But I wanted to put it out there because, we got to think about this. Things I wouldn't need, set line of sight. I wouldn't need to do that, right? And one thing to note is if we go to find all references, let's take a look at all the references that use the set line of sight. Okay, so finding all the references, these are all the places, I always think about this, these are the voyages, these are all the places that that it's going to break, right? Because look, it says decision tree get line of sight node, all right? That's where the line of sight condition is working. M_tree set line of sight node. So set line of sight, get line of sight node. These is where all the stuff, okay, M_line of sight node inside of the line of sight condition. So this is inside of this piece altogether. So most of it is in here. The .h and .cpp. But where do we actually set line of sight? Well, do we? Is there any place where we actually get or set line of sight in the form from the line of sight condition? Take a look. Like any ever, is there a place where we set or get line of sight, right? Well, we only mention it here in the condition itself. So this is where we actually do it. And if we click on, how I got this, by the way, was I just right-clicked on the line of sight condition. I right-clicked and then I just said, find all references. That's what this thing is. So it had 16 references, but a bunch of them were inside of the line of sight condition CPP and .h. Decision tree has making a line of sight node. All right, that's where it is, set line of sight node and get line of sight node. We can set all those things up. That's where that is. And we can go down here. If we scroll down, you can see that line of sight condition and close combat enemy. Here's close combat enemy. It's set line of sight node for the close combat enemy. Hey, look at that, right? And the range combat enemy. Well, that set line of sight node there too. But there's no place that we ever use that has line of sight and all that stuff of the line of sight condition. We don't have that, right? So it's almost redundant, right? That we have a setter and a getter here. And that's why it's okay for us to delete it. So if we did this and we said, okay, we don't have a field that we want to keep track of and the line of sight condition node. And so we wouldn't need a setter. Okay, we don't need a setter, right, at all. We just need to keep track of when we return the condition, whatever the condition is, we're going to poll the agent itself in order for us to know what the condition is, whatever the condition, the agent is that has that condition. So this is broken, of course, now, but how this looks is, okay, sure, we don't have a line of sight condition, so we're not going to set anything here. So how does this work? And I'm going to come back to this piece right here. Line of sight condition with a line of sight. Okay, well, we don't need this, so that can go away. But here, right, remember that our node, our line of sight condition itself, is a condition node. Go to definition for the condition node. And our condition node, right, our condition node is a tree node. Go to definition for that one. And our tree node has all these things. Tree node, my name, left and right, and his leaf. Okay, just putting it out there. So this is kind of the hierarchy of what this looks like right now. Okay, so far so good. Let's skip back, and you can use the back button here to skip back to where we were. So that's our line of sight condition. Our line of sight condition is of type condition node, and our condition node, right? Our condition node is of type tree node, like we said before. So here's our condition node. Our condition node is a tree node, right? And if we continue thinking about this, right? Here's our tree node, go to definition for the tree node. Well, wouldn't it be nice if our tree node, all of our tree nodes kept track of, every tree node kept track of the agent, that the tree node was part of. So it can kind of loop back and know what the agent is that is attached to, almost like a parent, right? Because tree nodes are attached to, when we set up a tree node, and just to, I want to show you what I'm talking about here because it's a little bit confusing, but let's take a look at our agents. So if I looked at our close combat enemy, which is an agent, right? Then our agent, right, has nodes, right? So when we build a decision tree, we have a decision tree pointer, that's the tree, and we have our build tree function, go to definition. Here's our go to definition for the function, and we add in a condition node. Well, the condition node, as an example, itself, it would be nice if each node knew what its agent is, the thing that has the build tree function, a way of looping back to the agent. We can set the agent right here. There's our set agent for different nodes. But for action nodes, right? Action nodes allow us to do that. Right? So if I go back to our action node.h, action node has an agent, okay? But condition node, our poor condition node, does not. And so what we want to do is we want to keep track of our agent as well here, okay? So here under in our condition node, we want to have normally we would make it private, but we want to have access, we want to give access to our anything that derives from our condition node. We want to have them access to the agent as well, right? Which means derived classes to have access to it. We can't make it protected. We can be we can't make it private. We can either make it protected or public. Public doesn't make any sense. So protected is the right thing. Typically, the rule for protected, just to put it out there for you guys, is we use protected sparingly. Usually protected is there to solve problems when we're coding. So we want to make an agent pointer here, right? And I typically would like to also include the agent.h here, up here. Okay, that's, oops, this is actually the wrong place. I'm doing it in condition node. Hold on, I want all tree nodes to have them. And then we'll update those because, let me just go back to this and let me explain what I'm doing here. So we said that our condition nodes, our action nodes, which are tree nodes, already have an agent, right? But we also need them. We also need them here in condition nodes, but they both inherit from a tree node. So this is a case where if two child classes, action node and condition node, if they both need access to an agent, it makes sense that the agent class itself would have the tree node itself, the superclass, the tree node, this one, would keep track of the agent, okay? Because both the child classes, action node and condition node, need them. Action node already has it, and condition node doesn't, but it will, so then might as well put it in the tree node. Hopefully that makes sense. So tree node, let's go back up here for a second to tree node. Tree node, for now, it's a struct, and it uses a default constructor. Let's change this so the constructor is not defaulted anymore. And instead, we'll just write the constructor function here so it doesn't break too many pieces of code. We'll say that is where it's going to be instantiated. Remember the difference between a struct and a class. By default, classes are private and structs are public, but we want to protect our agent. So we want to make it protected, and we're going to make an agent pointer, which we're going to call m_agents, okay, here. And when we do this, we need a getter and a setter. So let's do that next. So we'll say agent pointer, get agent. And that's going to, we'll code it right in here. We'll make it return m_agent. Oops. Go. And the setter is going to allow us to set the agent pointer. Okay. Okay, there it is. That's something that we can do. So those are the two little functions we can put into place. And then inside of our constructor, we can say agent is equal to, we'll just initialize it to null pointer for now. All right, so that's kind of something we can do. Now let's take a look at some of these underlines and see if we can take care of them. So tree node says, it says that move implementation out of class scope. No, we're going to keep it in here because otherwise I'd have to add a CPP, and I don't want to do that right now. This one, it says replace m_name with m_name, readability, redundancy, redundant string in it. All right, because you don't have to do that. It says it's not necessary to do that. I agree, because it's already an empty string by default. These just are naming condition things. What about this get agent? Get agent says add virtual declaration specifier. to this one, or make member function const, right? Because that'll be something that looks like this, const. Well, yeah, that makes sense, right? And then it says, well, if you're going to do that, then add a no discard. Well, that also makes sense to add a no discard, right? So that makes sense. Set agent. How about this one? Set agent. It says make it virtual. No, I'm not doing that because it's going to basically it's going to always return the agent. So there's no need to make it virtual because we don't need to override anything. All right, so save. So that is our tree node class. Well, if this is the case, okay, going back to our little condition node and action node, well, action node kind of overrides the agent, right? So, this is where our action node and condition node and all that stuff is something that we need to think about, right? So because we already have agent described inside of tree node, we don't have to describe it here. That's not necessary anymore. So let's change our action node class so that we don't need this private piece in here as well at all anymore. And which means that we are not going to instantiate or initialize our action here. That doesn't make any sense, right? And we have our action, which is pure virtual, and a default destructor, but we don't need a getter and setter in here because we've already defined these up in the superclass. So there's our action node changed. Save. The functionality will be the identical to what we had. All right, but now we've moved up the functionality. The only thing that helps us, action node helps us with, is define whether or not our tree node is a leaf or not. In this case, it is a leaf plus the action itself, whatever the action we're going to override is. Okay. Remember, we're making it a pure virtual because we must override this abstract method. Cool. Condition node then doesn't need any changes because, well, condition node.h basically says everything is good, right? Because our condition node is a tree node, therefore it already has getters and setters. We've just added the functionality here by updating the tree node superclass. Once we've added the tree node superclass, we've added in our getter and our setter, it cascades down, this functionality cascades down to both the action node and the condition node. Both of those two things now have that capability. Now there is an underline here and it's going to say something like add override specifier. I'm not going to do that here, but you could totally do that if it's asking you to do this. All right, so save. And I've got these action nodes and the tree node is done. Well, that's good. That's good. So going back to the line of sight condition, this is where it all started. Our line of sight condition then, well, we can set the agent now. Before we couldn't, but now we can. And the way this works is we wouldn't do this here because our line of sight condition function doesn't work, right? We don't need that. But when we call the condition method, instead of checking to see if the agent itself keeps track of line of sight, well, the agent does. The agent tracks, not the condition. So therefore, we can just say something like, because this is a tree node, and tree nodes all have a getter that's get agent, we can say, hey, agent, can you tell me if you have line of sight? And that is the way we're going to do it, as opposed to the way we did it before. Here, our line of sight condition, it takes in a Boolean, right, as an example, our line of sight condition. And again, let's just save this for a second. I'm just going to put this out there to you guys again. So line of sight condition, we'll make a brand new line of sight condition. It says, hey, does it have line of sight or not? So if I go here and I do a get all references or find all references, we can see which ones have it. All right, so we have set line of sight node. We can do that. We also set line of sight node here inside of our ranged combat enemy. So both of those two things are in our close combat enemy. Decision tree, get line of sight node, set line of sight node. That's what those things have. That's just in the decision tree.h and .cpp, so that's not a problem. Line of sight condition itself in the CPP and .h, but nowhere else. Which means that because we've never used it anywhere else, it's safe to say, that's why I'm pointing this out, it's totally safe to say that our line of sight condition does not need this Boolean. We can just remove that, right? It's just a default constructor function now. and which means that, well, this one can be set to default for the most part, because we don't, well, the only thing that changes is the name, line of sight condition, right? Why? Because we never said anything. Even if we took a thing that says set line of sight, we don't do anything with that thing. Okay, cool. We've made a change, and it's a cascading change. Guys, whenever we make a cascading change, we change action node, we change condition node, and we change tree node to add more functionality. Guys, we need to check to see if anything broke. So let's run it before we do anything else. Because when we make cascading changes like that, bad things happen to good people, and bad things happen, and we don't want that to happen. I know I'm going slow, and I do apologize, but okay, so there we go. So this is where I was worried, right? So let's see what the errors tell us. We have one error, and can anyone help me out? Why is this error happening? Set line of sight is not a member of line of sight condition. It says this up here. So get tree node, get line of sight node, set line of sight. Okay, so this is in our placing, and we can't do this anymore the same way because, well, our line of sight node isn't the thing that's keeping track of line of sight anymore. So this would be a no-go. We're not going to have this function anymore. So what would be there instead? Okay, so again, what I want to take a look at is our placing.cpp here. And then can you think about how this should change? So I want to set line of sight and, in our update function. So we have our updated display list, right? And we have this one, which is get line of sight. Well, remember what we can do, right? Is we can use our check agent line of sight to target, right? Which is kind of what this is, m_starship check line of sight to target, this piece right here, right? Well, it sets the line of sight for the agent already. So it's kind of redundant that we were doing it that way in the first place. So really all we need to do is, if we kind of put that in there, we just remove the stuff that was inside of this set line of sight node, because check agent line of sight to target, right? We have our target and our obstacles and our agent. So kind of get rid of this for a second. And let's go to check agent line of sight to target for a second. Go to definition. So if you look at agent line of sight to target, then okay, well let's take a look here what it's doing, right? Because pretty much, right, does this so far, does this set line of sight? Well, look what it's doing here. So I'm inside the agent. I'm inside the agent, and we get passed in this agent object. So here we're just setting the line of sight for this agent, but there might be another agent we want to set the line of sight for. So the only change we need to make here is whatever that agent was, that's the one we want to set line of sight for. All right. So again, this is the agent. We're getting an agent here in the check agent line of sight. And all we're doing is we're setting line of sight here for the agent, right? So what this does, because we're already setting line of sight, we don't make any other changes here. Once we've done this, then we don't need to have that complicated thing in here inside of our Starship. As soon as we check agent line of sight, well, we set it for the agent anyway. So that's kind of fixed that problem up. Let's make sure things still run as expected. And again, remember what I always want to try and do is any change we make, you and I together, we always want to confirm that our breaking changes didn't break our code, right? Oh, now this is bad, right? It says unable to read memory. Okay, so what happened there? How come this happens? So it says this was null pointer. So what could have caused the problem here? What could have caused the problem here? Why did we have this issue? So again, agent has line of sight, and it says has line of sight is this pointer is null, right? So this thing here, as an example, right at this point here, it says has line of sight is unable to read memory. Why? Why would that be a problem? Let's track it. Let's backtrack. So again, what we did was in the placing, we said, hey, for the starship, let's pass in the starship. Okay, that's what we're doing. And then the starship is the agent. Okay, think about this. The starship is the agent for the check agent line of sight. Okay, the starship is the agent for the agent line of sight. And then, cool. And then we're passing in the target as well as the obstacles. So what could be the problem here, as an example, and why am I getting a null pointer? So explain that a little bit. You get? I want to know more about what you mean. What do you mean starting line of sight? What do you mean by that? Starting line of sight is not set to false. Where would we set that? Where would I set line of sight if I can't read it? Where is it set for in the first place? Remember, we just made some changes way over there. Agent constructor. Okay, here's the agent. So in the agent constructor, what's right here, and here's our has line of sight. And if I go to the agent.cpp, here's the agent.cpp, and it's checking. Well, here's the line of sight. It has line of sight is false. So what would be the problem? I'm just following your logic for a second. Let's run it again. I want to see the error again, and I want you guys to help me out because this is kind of a key to all this stuff. Remember what we changed. Always think about what we changed first. So inside of the playscene.cpp, what we did, everything was working. If I comment this out just for a second, here, let's just comment it out, okay? And if I comment it out and run it, right, so I don't do this check, okay, just for a second. If I don't do this check and I run it, will it run? And will it break before the check is made? All right, yeah. Okay, so it broke. And so then, okay, cool. Where is the breakpoint? How come it broke? It says here, a line of sight here, right? It broke. And now let's look through here. Line of sight condition, which is this has line of sight thing, is checking to see if it has line of sight already from the agent, right? Our line of sight condition doesn't have an agent. Perfect. Right. There we go. Now we're thinking. So now let's keep going. Here's our decision tree. Look, here's line of sight condition, line 14. And then this is our call stack. Here's our make decision. Make decision goes, okay, well, make decision inside of our decision tree. Make decision says, okay, well, take the action, whatever the action is, based on that particular condition, right? That's what you're going to do. But there's no agent, right? Agent is null pointer. Agent is null pointer where, right? Where's the agent null pointer? We did that in the tree, right? We did this part in the tree. We set the agent as null pointer, right? In the tree node, yeah, we set it up. So we need to somehow, if I go to my ranged combat enemy, here's my ranged combat enemy update. Here's the update method, right? It's making a decision for my ranged combat enemy because that's the one it's going to, right? And our ranged combat enemy in our, down here in our build tree, right, as an example, there's no place ever that in our ranged combat enemy so far, okay, so if I was to look, let's just stop this insanity here, right? So here's our ranged combat enemy, right? And so again, ranged combat enemy, right? Is there any place where we set the agent in the ranged combat enemy so far, right? We haven't really. We never said that this is the agent for this particular thing. We have a bunch of line of sight nodes. There's a line of sight condition, but in the line of sight condition, we never really said, let's set the agent anywhere. Okay? We never did that. So that's something that we can consider is something we need to do, right? That we need to start doing now, right? Because we haven't really set the agent at all for the line of sight condition. So, okay. So what we need to do, if we're just going to keep this as is, just going to put this out there. Whenever we set up any node now, not only do we need to put it together, but we need to configure it here. This is the range combat enemy, guys. So what we need to do is something like this. We need to see that the line of sight node, right, whatever that is, right, you know, and I'm just putting it out there, whether it's the line of sight node or whatever, right, um, under the tree itself, we need to set it. So if I was to do something like m_tree and get line of sight node, that line of sight node, we want to set agent, and we're going to set the agent to this. That's what we need to do. Because if we don't do this here, then, well, the line of sight node doesn't know what the agent is. And my friends, we need to do that for every single one. m_tree. And I'm inside the range combat enemy here just to fix this problem. Get line of sight node, or sorry, get radius node, and we want to set agent to this, right? Maybe the radius node needs something, right? And the range combat node, you know, the range combat node, m_tree, get range, get range combat node, and the range combat node, hold on a second, set agent to this. And Yigit says, we don't have to dynamic cast action nodes to set agent anymore as well. That's correct, because all nodes have this. So patrol node, this is neat, right? Then it would be just something that looks like this. We can say, hey, patrol node, set agent to this. That's how simple that is, because we don't have to do any of that dynamic casting stuff anymore. Hey, move to line of sight node, set agent to this, right? And we'll do the other ones, okay? And we just can, instead of redoing it, I'll just kind of copy paste like this, or modify it. So attack node. So this is something that we needed to do, and what it did was it streamlined our code, but we also needed to do some of this. This is just keeping the code as is. And as I remember, I told you, I don't know if I'm gonna have the time to make changes to our combat node and so on. But that is kind of what we did, right? We kind of made it so that agents now, you want to set the agent for all these ones. Okay, let's go back to the placing and let's uncomment this line, because this line wasn't the problem. This line was good. It was something else. Let's run this thing and see if now it fixes the problem. Because again, what we want to try and do is get things in order. As soon as we make a change, we made changes to the tree node and everything else, we want to make sure that nothing breaks, right? And if it breaks, then that's a bad thing. And here we can clearly see it says performing move to range action, and we're all still good. Now, and only now, can we put this up to GitHub, because we changed we added agent, like an agent pointer to tree nodes. Let's do that. So CLS git add dot, git commit -m. We'll say added agent pointer to tree node. Yep. Awesome. That's fantastic. That's the first part. So let's see where we are. So again, we're running overtime as normal. You can see how long this has taken for everything to be done, but we've pretty much done all of this part, and we did all of this. Close combat enemy. We haven't reworked the tree yet. Tree node.h, it says moved agent in here from an action node. That probably could have been something first. So that probably, maybe in the instructions, I could have had it here, and then that's probably where it would have done, because without this, then our line of sight condition would have worked fine. Close combat enemy, we haven't done anything yet, you know, because we haven't kind of made our close combat enemy different. We're going to leave that as is. Really what we want to do is we made our range combat enemy, we made all these actions, that's all good. You know, the range tree diagram, I have it up here. and all that kind of stuff. But what we want to try and do is we want to switch up the ranged combat enemy a little bit, um, and we want to make the ranged combat enemy work differently, right? So that's something that we want to be able to do. And again, what I want to be able to do is I want to be able to add a couple of things here. I want to, whatever the enemy node, health node is, one thing we didn't do, let's do this in the .cpp for the play scene. Okay, again, just running out of time, and that's why I want to make this as fast as we can. So here in the starship, right, the starship itself has a tree, okay? And because the starship is a tree, then what we want to do is we want to, the enemy health node and the hit node, remember we've kind of established what those two things are, right? Enemy hit node and health node. I want to be able to add health to our ranged combat enemy. Okay, that's what I want to be able to do. So how do I do that, right? Where I want to, is there something I need to do that's different for the for the ranged combat enemy, the health node and the hit node, in order for me to do something here? And the answer should be absolutely there is more to do, right? So what we need is, if I go to the ranged combat enemy.cpp, let's take a look at this. Here's our stuff we've started to change. And I want to, our health node, really, if you think about this, that should be the root of our tree now. Okay, why? So here's where we're changing stuff. The health node is at the top. If we have health, then, as an example, for good, then we're going to check to see if we're hit. And the other part of the tree is the flee node. So here's the root. To the right is the enemy hit. To the left is the flee. Let's remake this tree this way, and then we'll stop for the day. I know we're going to run overtime, but please bear with me because this is going to be key for your assignment 4. All right, so at the root, we'll keep some of this stuff for now, but at the root, what we're going to say is m_tree, and we want to set the enemy health node, and the enemy health node is going to be a new enemy health condition, right, which what we want to set up. Okay, that's the first thing. So there's our new enemy health condition. And then m_tree, we want to get tree, push back the m_tree get enemy health node. Okay, so once we make it, we want to get it. All right, that's what it does. Now remember, when we made our enemy health node, we can always set agent. We don't need to, but we're going to. So set agent to this m_tree. Sorry, get. First we want to say get enemy health node, set agent to this, right? And we want to be able to do that just in case we need to have that agent running in the future, right? That's our configuration change we made, right? And why do we have to do this? Why even bother? Well, a couple things. We could have made it inside of the conditions. We could have changed each of these conditions so that it kept track of whatever the agent that is adding it. Our agent in this case is the enemy ranged combat enemy. And we need to do this every single time. If I need to do something every single time, there's ways around doing it, right? Because, well, I'm instantiating a new object of type enemy health condition. I could pass in this to the enemy health condition as an option, right? So, example, if I go back to the conditions, again, this is a coding thing for later, okay? Enemy health condition in the constructor function, all it takes is, am I healthy or not? That is what it takes. And by default, the answer is yes, I'm healthy, right? But enemy health condition, I can have a second constructor that also takes in the agent. And then I can set the agent to that thing inside the constructor function. So that is also an option, which means that because enemy health condition, it's going to be for every single node. If I go to condition node, go to definition. Because this is something that I can do for every node, condition node is a leaf, is different. And it's part of the tree node, go to definition, right? Go to definition. That means that in the constructor function, there's a couple of them I can have. I can have a constructor function that is the agent, where the agent is null pointer. What else could I do here, guys? How could I make it so that I can make it so that I don't have to do all that work where I say this set agent anymore? I don't want to do that set agent stuff. That's not very efficient, is it? Because I have to spend another line of code. What can I do here to make it better? How would I rewrite this or add to this? What would I do? Okay, so the question is, just to go back, I'm always doing this. Set agent, set agent, set agent, set agent. I'm doing this over and over again. And I'm doing it constantly. Every single time I make a brand new agent, I add all these things. There's extra configuration, right? I don't want to do this stuff anymore because I'm doing it every single time I add a node. Every single time I instantiate a new node, I'm adding it. Guys, I don't want this. I want it so that it's just easy for me to do, right? Is there a way of doing that? That's my question. Answer is, I'm not getting an answer from you guys. So let's think about this. It's all down to inheritance again. So if I go back to tree node, what if, I'm just putting it out there, what if I had another tree node constructor and the tree node constructor took in an agent? Okay, here's something. That is also an option, right? So there's one that has nothing, right? And there's one that looks like this, right? Okay, that's definitely a way of doing it. What if I did something like this instead, where I said, okay, well, what if I had an agent pointer here, and we'll call it agent, and that is going to be equal to null pointer. Is that something I can do? So this rewrites the default constructor, where by default, if I don't say anything, then I pass in an empty agent. That's what it does. I pass in an empty agent. Uh-oh. It's going to break me if I do it this way? Because, I mean, I'm adding in a brand new agent. And remember condition node? Condition node, well, the condition node, it has a super constructor that's being called, and the super constructor is not being told anything about whether or not it's going to be passed in, that is going to be passed into it. So, oh man, that means here inside of the condition node, I'm going to have to pass in an agent, right? And the agent pointer, which is going to be called agent, right, is going to be null pointer by default, null pointer. And then what I'm going to say is I want to satisfy the requirements of my super constructor, which is the constructor for tree node, right, where I pass in the agent object, whether it's kind of put in or not. If I pass it in, wonderful. If I don't pass it in, good. Okay, so it becomes null pointer, right? Does that make sense? Okay, so just follow my logic here for a second while we go. So that's condition node. Then there's action node. Remember that action node also? We have to fix that one up too now. So action node.h, here it is. Action node, again, what we want to do is satisfy the constructor. So we're going to take in an agent pointer called agent. And we want to satisfy the constructor for tree node. And we're going to pass in the agent pointer. And by default, the agent pointer should be null pointer. There's null pointer, right? Is leaf in his tree. Nice, nice, nice. Everything is good so far, right? No changes to this one, because basically if I don't pass an agent, then it's set to null pointer, and this agent is where agent's going to be set. No real changes so far. Condition node, same thing. I'm making it so by default it's null pointer, and I'm taking whatever the agent, the person passes in and into there. Uh-oh, but what about the other ones? Let's go into all the conditions for a second. So let's just look at line of sight condition. Well, line of sight condition has no way of taking in whether I have an agent or not, right? There's no way, I can't. And I'm not doing it in my ranged combat enemy. Let's go back to my ranged combat enemy agent just for a second. I'm putting it out there. I'm just saying, I'm trying to troubleshoot with you to see how this works. So here's my ranged combat enemy, yay. And in my .cpp, right, I instantiate an object of new enemy health condition, or line of sight condition. But line of sight condition, go to definition, does not take any other types of things, whether I want to take a something in there or not, which means each one of these things also must take by default, a line of sight, a agent pointer, right? That's the way to fix that problem, which means, right? Because these are all of condition node, and condition nodes are all of tree nodes, and tree nodes all have that stuff. This thing that we keep on passing around, we need to pass this through the entire way, right? From one to the other, so that tree node is satisfied. Okay, that's what it is, because tree node is a superclass. So we have to keep on satisfying the superclasses of the superclasses of the superclasses. That's how it works, right? Which is, well, confusing, right? But let me talk about this in a second. If I wanted to just avoid doing this line, right, which is this one line of code, then I need to switch all these ones. So every single one of these things. So here's an example, enemy health condition. Let's just do it for one. Enemy health condition.h, right? Enemy health condition.h, right now, it takes a healthy or not. That's what it takes, healthy or not. And I need to add in an agent, right? So that's something it's going to take too, agent. And by default, that agent is going to be null pointer, right? So that is something that we're going to take too, right? So I could send in an agent or not, healthy or not, and it has to be in this order. Okay, if I'm going to push in something that is by default, if I want to change it to what something else, then I've got to make sure that this is the way it is. Okay, so this is how this is. And if I go to definition, sorry, let's go to this one. Well, this one also has to have that. So it's going to be an agent pointer. We're going to call agent, which is going to be here, like so. And then what we're going to do is, well, I want to set the agent for this object, right? So I'm going to say something like set agent, right? I can do that way too. I can set the agent here instead of passing it through, right? The thing. Or here's something, because I'm just using the constructor function, and because the enemy health condition is of type condition node, right? Then I can just say, hey, condition node, let's pass in my agent, right? Does it exist or not, right? Does that make sense? This idea? Well, let's see if it works. So let's go back to my ranged combat enemy. And, well, what if I wanted to put in this? Is that allowed now? Well, health condition says that because it's a public node, let's do this for a second. When I established it, it says, here's the options. I can say that the agent is null pointer, and I can also specify that it's healthy or not, or I can just pass in this, and I can specify if it's not healthy. I can do that. That is possible, part of it if I want to. If I just specify this, then I'm only specifying if it's what the agent is. And if I did this, then I can take away this part right here. I don't have to set my agent anymore. Does that make sense? Guys, check mark if it makes sense, X if it doesn't. Okay, so why? Why would I even bother doing any of that? Because of my code. I know this is a long-winded one, guys. I'm so sorry. But look, I have so much redundancy in my code. Here, everywhere. All this is redundant, right? And I can take away this, but I need to build in some more intelligence in some of these nodes that I have, right? Which means, let's just do them really quickly, okay? Ranged combat condition. Ranged combat condition takes a Boolean, by default it's false, but it also will take in an action node. Sorry, not the action, agent, which we're going to say is this, right, agent. And that means that I need to change the CPP for the ranged combat node so that it also takes in an agent, and that it also has a satisfies the super constructor, which is the condition node, which passes in the agent itself, whatever that agent happens to be. And let's make sure that the ranged combat condition agent starts off with as null pointer so that it doesn't break anything. Oof, right? Copy paste, copy paste, copy paste. Radius condition. Radius condition. It needs to take in an agent. Right? Agent is a null pointer. Cool. All right. So radius condition. Let's go in there. And we're going to say agent. And we're also going to call the superconductor constructor for condition node, where we're passing in the agents. Okay. And we're going to do that for the next ones. Sorry, guys. This takes time. So why did we not have to satisfy the condition node before? Well, the condition node never had it, never had an agent to pass in, right? We didn't care about it because it was all null pointer the entire way through, right? But here, as an example, now we're caring. Now we care, right? We're building in some of this functionality, right? Just gonna keep going. You guys aren't stopping me anyway, so I'm just gonna keep coding. Hopefully you get it. Did this one already. This one. It's not, again, it's not that long. It's just a breaking change that we have to take care of, right? So um, one thing to note also, one thing to I also have to say is whenever we have a default parameter, remember we have one here. If we put one here, both of them, I mean, if I have one here, then this should also be a defaulted parameter. You can't have one here but not one here, right? The last one has to be, kind of a default parameter if I have one over here. Okay, so that's kind of a syntax. They both have to now. But I'm doing different things with them, right? Okay, cool. That thing does it. Let me see what it says. Insert this, which it did here for, okay, I see what it did. That's nice. I'll do the same thing just to fix up some of this stuff. Yeah, lots of little changes, but nothing too severe. All right, and let's just check them one more time. So this one's okay, but we may as well do one of those. That's what it's going to ask for anyway. This one's okay. That one's okay. That one doesn't have it, so we don't care. That one should do it. Why not? Same thing with this one. And that one. All right, so those are all done. Now, those are the conditions. How about the actions? Those are all have to be done too, right? Because now these ones, they're going to have an agent. Right? And we'll do these ones now. agent pointer. So this is now, this is action node, right? Because it satisfied the conditions of this one, right? So that's how it goes. So I'm just going to copy paste this one here so that we don't have to do it too much, and go into the next one here. So action agents. Okay. Actually, we can just kind of do one of these about that, because all of them are going to have that. So save. Sure. Places we can have issues, but we're going to check them in a second. And last one. Right? Craziness. So again, um, covering this for you so that you understand how you could do it differently. And I've gone through a long way of doing this. Now we have to test it. So the simplest way to test it is with what we already have, as opposed to testing it with the brand new stuff that we're going to supposed to do. So again, if I go to agents and if I go to range combat enemy .cpp, right, we certainly could use set agent. That is definitely an option. Or we could do this. For now, let's just comment this out. Instead of changing our tree, right, just for a second, what if I just did this? So I said I want to pass in this here, and let's just comment the stuff out so you can see when this is done. So this is where it's going to be. So this is this. Anytime we have set agent, we can just do it automatically now with reducing some of these lines of code, right? Which I know it doesn't seem like we're gaining anything, but actually what we're doing is we are, as soon as we do this kind of stuff right here, then future, we're actually safeguarding our the future way of doing things, because what this is doing for us is it's going to save us coding later. If we add more agents in the future, we wouldn't have to do all this stuff. We just pass in this and we're good to go. Kind of makes it in one, this kind of stuff. So if everything goes well, and if we didn't do anything wrong, we didn't break anything, and then we're still starting out as this is the root node, the set line of sight node. So theoretically, that if we didn't break anything, we should just still work. Let's just run this thing and see if it breaks. And if it does, we can trace it and see what happened. If it doesn't, we're good to go. But this is a big change because notice like it's a cascading change. We started at the very top and we've kind of a domino effect of when we changed our superclass, we've changed all the classes that are underneath it. Those are all the changes we need to make. And we did that to facilitate easier coding in the future, right? Otherwise, we'd have an issue. You can see here that it's clearly all good to go, right? So that was our change. And we did that before we added stuff in. So we're going to say we can now dispense with this stuff. We don't need this anymore. All these things, we can get rid of all this extra code. We don't need it anymore because what we've done is we've removed the need for any of this stuff to happen in the first place. Does that make sense? So again, a bit of some refactoring, and normally I don't like doing refactoring too much because, you know, as I say, make it work and then refactor. But in this case, it was so glaring, like to me anyway. I don't know, maybe for you, you were okay with it, but I'm not okay with it, right? If I have to do this over and over again, like that's a lot of the same code over and over again. Where here we just do it in one line. Look, I'm just doing it here. It's nice and simple. When I instantiate it, I pass in a reference to the agent and I'm good to go every single time. So that to me speaks to me more than anything else. So let's save that and put that up on GitHub. So we'll say added an agent pointer to the tree node class, right? So again, git add dot, lots of changes. Git commit -m. We'll say added agent pointer. It's kind of an optional, added optional agent pointer to tree node constructor. And that made a change to all those objects, right? Like we updated a bunch of files, like 42 files we just changed, right? Like that were kind of done in very short order. So that's a lot of changes we made in a very short time. But the reason why we did this is because it makes our agent a little bit more resilient now. And so we don't have to do that same stuff. Okay, good. So now let's get back. And I know this is long and I'm going to run over time. Like I said, guys, if you have to go, I'm going to keep recording for you guys. But here I want to change over to what we did here. This map here. That's what I want to do right now. Okay, so again, back to this. So I want to start with a health node. Here's our health node. And we want to push back our health node. That's the first thing. Then, okay, on the left node, there's the left node and there's the right tree node. So the left tree node is going to be our new flea node. So we're going to say tree node pointer, and we're going to say the flea node is equal to m_tree, and we're going to add node, and we're going to add node the get enemy health node, get enemy health node, followed by the new flea action, a new flea action, right? Which is going to make me Alt enter. It's going to make me import that stuff. I'm going to pass in an agent, which is this. That's the option. And then I'm going to specify that it is the left tree node. So tree node type, left tree node, where it's going to go. Okay, so that is the flea node. And the flea node, again, is this one. Okay, so that's the flea node. And then I'm going to say that m_tree, get tree, and then push back. And I'm going to push back our flea node. There we go. All right, so that's kind of how easier it is. And so I don't have to do that set agent anymore. So that is our left tree. So left subtree. Okay. For the right subtree, so here's our right subtree. So what do we do for the left subtree? So this is the root, right? Here's a root node. Left subtree is just a flea node. The right subtree is our enemy hit condition. All right, so what we're going to do is we do something different here. We're going to say that we want to m underscore tree, and we want to set the enemy hit node to a new enemy hit condition where we're going to pass in this by default. And then we're going to add the node. So add node m underscore tree get enemy health node. This one we just did just now, this one. That's the enemy health node up there. And then it's going to be the m underscore tree get enemy hit node, which we just defined. Okay, so that's another way of doing the same thing, where that is the tree node right subtree. Okay, that's the way we can do that. And then we can just say m underscore tree push back blah 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 blah. But instead of pushing back the flee node, we want to push back the get enemy hit node. Gets m underscore tree get enemy hit node, which we just defined. Okay, so we defined the hit node, and we're going to push that one back onto the tree. So we know the order that it's being pushed on. So that's the right subtree. And now this becomes the right tree root, the hit node, right? So now we're going to do the left subtree and the right subtree. Okay. So this is the right subtree. We'll call this right subtree root is what this is going to be. And now we're going to do the left subtree. So left subtree. So how does that work? Left subtree is going to be, this is the left subtree root. Left subtree root. The next left subtree root, we'll say next left subtree root is going to basically be the player detected, right? And again, player detected is a new thing. So let's do that. So we'll say m underscore tree. And then we want to set player detected node to a new player detected condition, right? Which we're going to pass in this. Okay, so that's the first thing. And then just like before, and we want to add node, and we want to look to the top, right? So this is going to be the root, which is going to be the enemy hit node. The enemy hit node is going to be the root. So this is gets enemy hit node. So hit node is going to be the root of this subtree root. Okay. And then what are my children? So again, the child node is going to be this one we just made, which is the get player detected node. Get player detected node. That's that one. That's the get player detected node. That's going to be the child of this one. And this will be the left tree node. This is the left tree node, okay, that we want to add in. That's the, and then what we want to do is we want to push this back into the tree itself. So we're going to do that now. So get tree, push back, and we want to push back the get player detected node. Get player detected node. All right, so that is our left subtree root. Okay, so that's the right subtree root. That was in the middle. That was this one. That's our left subtree root, right? And then there's our right subtree root, which has line of sight. Okay, so has line of sight is a new line of sight condition that's going to be our next right subtree. So next right subtree root. Like, so this is the next level. So this is the root, the initial root. This is the initial left subtree. Left subtree, let's say level 1. Right subtree, level 1, right? Left subtree, level 2, right? That's the left subtree level 2, right? So this is level 1. This is level 2, right? And this is the right subtree, level 2. Okay, as an example. Maybe that's the best way to look at this thing. when it comes to, coding it the right way. Okay, cool. So then what I want to do is I want to establish a line of sight node. We already have a line of sight condition here, right? And this is kind of what we want to do, but instead of making it the line of sight condition of the root, we want to kind of do this as a line of sight node right, line of sight node left. Why? Because we have two. Here's a line of sight node right, and then we're going to have another one over here, line of sight node left, and we should differentiate between the two of these. All right, so I kind of want to reuse this one, okay? But the way I'm going to do it is I'm going to set a new line of sight condition pointer, and I'm going to call this line of sight node right, and that's going to equal to this new line of sight condition when I pass in a reference to this. Hey, that's what it's going to be. And then I'm going to add node, m underscore tree, add node, and I'm going to add node my parent. So parent to this one, the red subtree right, is the enemy hit, which is the one I want to use, the get enemy hit node, this one. Okay. And the child will be this one here, which is the new line of sight condition called line of sight row right. That's the child node. And then it's going to be the right tree node. So tree node right. I'm adding that in. And then I'm going to push back, which is this right here. So push back, but I'm not pushing back the line of sight node. I'm pushing back this one here because that one's the one that I want to push onto the tree. Okay, line of sight node right. Okay, line of sight node right, blah, 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 line of sight condition. These are good. And that's the level of the right subtree level 2. Okay, so that means this one. I want to go back to this one, and I want to do the left subtree level 3. This is level 3 now. So again, if you think about what I'm doing, again, this is level 0. This is level 1. This is level 2. I've done these two already. Now I'm doing this one. Okay, here. So patrol. So patrol, let's clear that up. Is the next one. I don't need this one anymore. This is gone because that was my original one. And I have a patrol node down here that I can reuse. So that's going to be the next subtree. So I'm going to grab this part. And this is an action that I'm going to take. But the actions are going to be here and there because of the way it works, right? So here, this is going to be the left subtree of level 3. Level 3, right? Left subtree, right? So I'm making a new patrol node. I'm adding the node in, and my root node, is the player detected subtree node, right? So player detected is what that's going to be, which is, well, get player detected, this one, right? So get player detected, that's the one, right? And for the patrol node, I'm going to make a new patrol action this, and this is the tree night is left, the left tree node, that's still good. And I'm pushing this back, I'm pushing the new patrol node up to this thing. So that's the left subtree level 3. I'm going to do the next right subtree. So right subtree level 3, right? And this one here, if we look, is the has line of sight. Uh-oh, there's another has line of sight in here. And this is similar to the load line of sight node right. I'm going to make a line of sight node left. I'm going to grab this one. And I'm going to put that in here. And I'm going to say line of sight node left is a line of sight condition. And it's going to say the root node, right? Line of sight node left is the player detected node. So that's this one. And line of sight node left is the one that's going to be the child. It's going to be the right tree node, just like this one's the right tree node, right? And I'm going to push this line of sight node left up into the tree. Okay, so that really, when you think about it, that's the left subtree, right? And this is the left right subtree, left right, whatever you want to call that. Okay, just to keep track of it. Now I'm going to do the right left subtree, right left subtree level 3, so we know which one it is. And the right left subtree is wait behind cover. We don't have that one yet. We need to make that wait behind cover node. So we're going to say tree node pointer. We're going to call this the wait behind cover node, right? And that's going to be a I'm going to do it in one. I'm going to do it with add node. I'm going to add node the line of sight node right as the parent. So line of sight node right. The child node is going to be a new wait behind cover node. Wait behind cover action node. That is a new node I want to put in there. So Alt Enter is going to allow that in. I'm going to pass in a reference to this. And then I'm going to decide that the tree node is going to be the left tree node, right? Why? Because it's here. The right left node. Right left node. Okay, that's what that is. So that adds it to the tree. And then what we want to do is get tree, and we want to push back the wait behind cover. So that is the right left. Now we're going to do the right subtree level 3, and where we have the move to cover. Okay, move to cover. Again, this is a brand new action that we've never done before. We've done set radius and set move to line of sight, move to player, and attack, right? We've done these, but we've never done a move to cover. So that's new. Cover node. And we'll do the same thing. And pass in the, again, it's the right line of sight. Line of sight node right is the one that we want there, followed by a new, and again, this would be called the move to cover action. We'll pass in this, and it's going to say Alt Enter, add that in there, followed by a tree node right. Okay. And then we're going to m_tree, get tree, push back, and it's going to be the move to cover node. There we go. So that takes care of level 3. Level 4 has nothing in the patrol, so that's the patrol action. So the left subtree was the patrol action. All right, so this is the patrol action, right? And these are all conditions. So condition, move behind cover node, right, as an example, and wait behind cover node. Those two things are also actions. So move behind cover and this one, wait behind cover. So this is a wait behind cover action. That's what that is. And this is a move to cover action. So these are some actions that we're doing, and there's a condition. This is a line of sight condition. So we're mixing actions and conditions now because our tree isn't the same balanced tree that we had before, right? It's kind of looking like this, right? All right, cool. So we've done level 3. So 1, 2, 3. Now we need to do level 4 and level 5. Level 4 is simpler because it's going to go to the left line of sight node and it's going to be moved to line of sight. Okay, good. So that's going to be the left node, left subtree, level 3, level 4, right? And the left subtree level 4 is going to be this move to line of sight action. Okay, move to line of sight action we already have, right? It's move to line of sight node is what we want to use, right? So we had a move to cover node. We can use this move to line of sight node right here, just cut it and put it right here. And now the only difference is that the parent for this one has to be the left line of sight node. That's the parent. So left line of sight node left. There we go. That's the parent. And the move to line of sight action is what we're going to instantiate for the first time. And instead of it being the right tree, this is the left tree in this case. So this is the left tree node. Okay, there we go. So that pushes it all on. That's the left subtree level 4. Left, right subtree level 4, right? And this is the site action, okay? This one is the within range condition, the range condition, okay? So range condition, we have one down here that we can look at. Set ranged combat node, range combat condition. This looks pretty good. This looks promising. The range combat node and all that kind of stuff because we have it already. So we're going to take this puppy right here and cut it and put it up here. And now let's see if this works. So first we set the ranged combat node to this. So this is the ranged combat condition. Okay, I'm just noting them so you can see which one's which. And then add node. Now what is the parent? The parent is the left line of sight node. So that's the parent. So this has to change. Left line of sight node left. Line of sight node left. The get range combat node is something that we're going to put in there. And this will be the right tree node, right, within range, which is correct. And then we're going to put this onto the tree. Done. Excellent. So that is this. Done. Okay, now we need to do the left subtree level 5. Left subtree level 5. Okay, and this is going to be the move to range action. Move to range action. Do we have such an action? Well, we have move to player node, right? We have move to player node, and that is kind of we just renamed it. That is really the get range combat node is what this is. So this is the move to range node. This should actually be called, let's just refactor rename this. I kind of renamed this wrong the last time. Or we just didn't, we just kind of copy paste it. Move to range node is what this should be called. Move to range node. And we'll just grab this thing right here. And this is going to be the move to range action, which is what I need over here in the left subtree level 5, right up here. So let's make sure that the parent is right, because the parent has to be the range within range method. Move to range. Am I within range? Okay, range combat node. Yes, it's correct. Right, set ranged. Am I ranged? That's the range condition. I'm doing this. And move to range action. That's this. That's a brand new move to range action. And this is the left tree node, which indeed it is. Okay, so that's pretty good still. So we can reuse some of that code. And we're going to push that move to range node up. The last one is the attack. So we have the attack subtree, and this is going to be the right subtree. So this is the right subtree level 5, right? And which is the attack action, okay? And really, this attack node that we already have, or we can use, and you can see that this set radius node we don't need anymore because we're going to use the detected. And we can get rid of all this. So set radius node we just removed from this whole thing because we're doing it differently. So attack node, okay, again, it needs to be get ranged, which is the get range combat node, just like this one. A new attack node, and it's the right tree, and it's going to be pushed back to here, and that's everything. That is the new tree we rebuilt for the new. So no more conditions. This is kind of a mix of actions and conditions. So again, the root of the tree is the health condition, just to make sure. Level 1 subtree is the flee action, right? You can see that. This right subtree is the enemy hit condition, okay? Just to be very clear on this thing. And this level 2 is the player detected. There's your radius right there. Player detected condition, which is kind of superseding what radius was. This is the left line of sight condition. So these are all conditions so far as we swim through the entire tree. There's a patrol action line, that's the right line of sight condition. This is the left line of sight condition. There we go. And you can see I've just documented it all, so you can, when we put this up on GitHub, you'll have everything. I know there's only a few of you left, but hopefully this makes sense for all of you. Okay. All right. Excellent. So that's kind of where it was there as we're starting off. So there's the build tree, and we can see how we're building this up here, to make it a little bit more, like I said before, a little bit better in terms of how this would work. Now, question for you guys, there's only a few of you left, but do you think we can run this thing? Is there anything that you might see as a problem to any of the stuff that we have here? The enemy health node, that's something that we never set up. So here's something that we probably have to do to change if we're going to test this. First, let's go to our scenes. And if I go to my playscene.cpp, then in here, where the starship is here on the left, maybe what we can do for the starship is, kind of, we want to add that health condition in. So in order for us to know that the ship has been hit or not, we can say m_p starship, and we can get tree from the starship itself. That's the agent we're looking at. And I want to get the enemy health node. And what I want to do is set health. Remember, I can set health to a value, and I can check to see if my target, that's me, right, has health. Okay, well, look at this. So my target, I want to get health on the target, okay, but I can't get health on the target if the target's health is greater than 25. That's like if I was to look at the target. So how do I do this? Because target, go to definition. Because remember, my spaceship is the tree. Target, right? As an example, if you think about what target is my main ship, right? As in, this is the get enemy health node, right? As an example, and so I want to set health, to a value. Let's go back to that. I want to set health to a value of, remember, set health is either true or false. Am I healthy or not? Right, kind of stuff. Here's something. I want to m_p starship get health. If my health for the starship is greater than 25, then it's true and we're good to go. That's what that is, okay? Next. m_p starship, and I want to get tree, and I want to get enemy hit node, okay, and I want to say is hit by default. I want to just instantiate it to false by now, by just set it up as false. So it's not hit by default. So I set up both the enemy health node and the enemy hit node to false. Again, enemy is kind of a weird thing. It's almost like I want to set the starship health node and hit node to and initialize it as we go. So that's what this does. Okay. So, all right. So that sets up, this kind of sets up our range combat enemy. So we'll say sets up range combat enemy, right? And we also want to do a distance check, right? So check agent line of sight. Basically, that checks to see if we have line of sight between the starship and the obstacles and the target. Can I see the target? The target being my big ship in the middle. Can I see it? And that's what's going to generate, do I have line of sight or not, right? But I also want to do a distance check. Let's do a distance check for radius or detection radius, right? And the way this is going to work is we're going to say float distance, right, is util distance. And we're going to pass in m_p starship get transform dot position. There we go. And we also want to get the distance between there and the target position, m_p target dot transform dot position, right? That is going to be the distance between the two. Distance check for between starship and target to for detection radius. Okay, that's what we're using for. And then we're gonna basically say, so bool is detected. We're gonna say is if the distance is less than something like 450. So radius detection, right? And we'll say this is just outside of line of sight range, because remember our line of sight range is 400 for our ship. Our ship can't see farther than 400, but we can, our radius is 450, okay? And then we're going to say m_p starship get tree get player detected node, and we can set detected to is detected. So remember, player is the target. That's really the target. Get player detected node. We're going to set the target, is it detected or not, by checking to see if this is true. We really don't need this Boolean, right? We can say just distance is less than 450. So I can do one of these, and I can put that inside of here. So instead of having an is detected method, I can just check to see if my distance is less than 450. And if it's true, then player is detected, right? And so we don't need this part right here. Okay. Okay. So that's one way we can do that. And then, okay. So what about is within combat range, right? So that is my range combat node. So this is the detection radius, but we also want to check to see if we're at the right position to fire our weapons, right? So that's something else we need to do. So we're going to say, again, if it's in ranged, then we're going to say something like under, so we'll say within line of sight distance, but not too close, which is the optimum firing range, right? That's what we want for this to be. And so M underscore P starship, we're going to get tree, and we're going to get range combat node. That's the range combat node. We're going to say set is within combat range. And the condition is going to be if our distance is greater than equal to 200, let's say 200 pixels would be the closest it wants to be, and if our distance is less than or equal to 350, so not quite too far, that's the right range, some kind of range that we're going to put it. So if this is the case, then we're going to say that we're in within range. And then we're going to still keep these. So that's the only differences we're going to make. We've just given more input. This is more input for the ranged combat enemy. That's what all it's doing, okay? If that makes sense. So that's what's going to happen there. All right. Now, to test if we're damaged and all that kind of stuff, we can make it hurt with a key code. So if I press the, kind of a key code like K, then we can test to see if it takes damage, and we can do that inside of my my input. So down in here in my player input, we have some scan codes for A and D and all that kind of stuff if we want to move things around. But we can add scan codes for if I want to. This is his key down, but I want to make it so that if it's pressed, I can do that. So here's my keyboard input, and right now I can switch from one scene to the other, right? But what if I want to make it so that I can do damage? I want to be able to do that with other buttons. So, because this is get keyboard input, and up here, this is if I want to get player input from my controller, right? So controller, or if I want to use a keyboard input. Let's do this part. So with keyboard input, I'm going to say something like if event manager instance. So I'm going to go through the instance method, and I want to say key pressed, or I can use this key down. It's not a problem. Key pressed and this key down. Let me talk about both. Let me try both. I'll show you what to do. SDL scan code, and we want to get SQL scan code K, let's say. So K would be the kill switch. So I press the K button, and then if I press the K button, then I want to do damage. M underscore P target, and well, so here's something. How come I can't do damage to the target, right? Well, what I really mean is I want to change the starship to take damage. Take damage to the starship, and the starship is going to be, let's say something like 25. That's the value that I'm going to take, right? So starship takes damage, right? And then let's do a C out. So we'll say starship at, this will be slightly different than what we did last semester, M underscore P starship, and we'll say get health, and we'll say percent, something like that. Okay, something different. There we go. So there's our key press for our K key. And then maybe I'll make an R key, R for reset. Yeah, it's pretty close, but okay. Make an R for reset. Scan code R, right? And what R will do is will instead of taking damage, will set health to 100. Set health, and we'll actually do that. We'll say, and we'll also say M underscore P starship, and we'll say get enemy get tree, that'll be okay. And then get enemy hit node, and we'll say that that is set is hit to false. And by the way, we should probably say when we do this, set is hit is true. So when I hit, I do damage, right? And when I'm hit and I do damage, then this is something I also have to do. Set is hit node to true, because we just took damage, we just got hit, right? As an example. And if we reset, might as well reset everything. So we'll say something like m_p starship, and we'll get tree, get player detected node, set detected to false. We'll say that the player is not even detected anymore. And we'll just say target condition has been reset. So we'll say conditions have been reset, right? So we can try it again. Okay, that's what that'll work like. So we can always reset and put it back. But the first time we take damage, we're going to set is hit to true, and this is going to be the thing that's going to test it out. Okay, let's see if this doesn't break anything, and can we run this thing now with some kind of action. So run. And if not, we'll just do some troubleshooting and to fix this problem. I know it's been a long one, guys. Like this is way longer than I planned, but it is what it is. All right, so here's something. So it says, performing move to line of sight action. Okay. So that's why, because we don't have line of sight, right? And our action functions are empty. Absolutely. So tell me then, what do we do when it comes to move to line of sight action? So here's something. If I move my target around, so you can see that it's going to start patrolling. Okay. And it's going to patrol, patrol, patrol. This is what it should do until something happens, right? So what happened here? What happened here that it stopped like this, where it says move to line of sight action, right? Here's something else. If I press the K key, right, the K key, K, it says performing wait behind cover action, and it says move to line of sight action. So right from wait behind cover to move to line of sight action. Why? Because our move to behind cover action didn't do anything. If I print it again, it says move, Starship at 50%, Starship at 25%. Now it's going to go to flee action. Take a look how it did that, right? And if I go back to R, it's going to reset everything back to normal. So now it didn't detect anything. But we're close, unfortunately, so it's still detected unless we move way over here. And then it's going to keep going until it detects us again. And why? We can't see it, but there's actually a radius that's here. And as soon as it hits us, there. Now it says move to line of sight action because it's detected us. Okay. So that's something that's happened. So actually it's working, is exactly what we wanted to do, right? But here's something, like you said, you get our action functions are empty. So back to the drawing board a little bit with our agent. So if I go with agent range combat.cpp, so here is our patrol, here is our move to player, right? That's the move to player action where it says set action state to move to player. And well, we need a couple of more of these, right? Because we didn't set up those actions. And without those actions like move to range, and we have move to player, but we don't have any of the other ones. So again, one thing to note is that inside of our range combat enemy.h, right, that we have a patrol and move to player, but we never just kind of overrode our other actions, right? And we need to do that, right? So just like you said. So so the ones we need, we have for lab 7 part 2. Let's make lab 7 part 3. So here's new for lab 7 part 3. And we're going to make a void. So we have patrol, we'll do flee, override. We'll have a void. Did I not do this right? Why is that not working? Override, oh, fleet. See what happens. Move to line of sight. We don't have move to line of sight. We want to override that one. We want to move to range. Move to range. We want to override that one. We want to make a move, wait behind cover. We want to override that one. We also want to move to cover. Move to cover. We want to override that one. And finally, we want the attack action. Right, void attack, and we want to do that. So those are the ones we don't have, and we need all of them to define them because otherwise they won't do anything at all. So let's go up here, save the ranged combat enemy, and we'll just add in generate definitions by declarations. These are the ones we're adding in. Finish. And it adds in all of these. So notice that this is the standard that we've been using, set action state to all these. We need to do that. So our move to player, our flee, it's going to be like this. So kind of our, let's just put that in like for now. So in our flee action, we don't have a flee state yet. I don't think. I'm not sure if flee is functional on our object. We have move. I don't think we have flee that's working. I got to check. But anyways, this will be the flee action. Okay, set action state to flee. Move to line of sight. So I copy this. Set our action state to move to line of sight. There we go. And move to range. Copy paste. Move to range. And a lot of little changes for this one. And move to cover. Say move to cover, this one, and this one. There's move to cover, wait behind cover, wait behind cover. Wow. Wait behind cover, right? And then attack. Well, that is just attack. Okay, we don't have actions related to these, but let's see, do we have, so this is build tree. We have our move function. There's our move function. We have our seek. I wonder if you guys had flee from before. I don't think so. And if not, then we could have built in a flee, which is the opposite of seek. So flee is this. We can make a brand new thing that does flee and it'll make it run away. Okay. But that's pretty much what it is. I think you guys have to figure this part out on your own because of just the way it works. But I think, yeah, so here you would do if we had it, a flee action. We don't have it, right? Oh, not there. This would be here. If we can do flee, then this would be doing flee. You would do a move to player, right? And whatever that is, move to player action, whatever that is. You know, we don't have that because this is the move to player thing. You could also program it here. Move to player, we'll say, how about this? Move to player algorithm. Here, right? Whatever the move to player algorithm is going to be here. And you probably want to do it right in here so that it's probably the same thing with move to line of sight. What is that? Move to line of sight algorithm. You have to program that. And the same thing goes move to range. So if I need to do station keeping, then move to range algorithm is going to go there. And the same thing goes with move to cover. Move to cover would go here. And wait behind cover would go here. Wait behind cover And then there's the attack action. Attack action algorithm. Okay, so that's all of them. The only one we have right now is move when on patrol. All right, let's try that and see what it does. And I think that's everything I should probably cover today, because I've gone way over in terms of time, and I want to stop now. So we're really supposed to finish at 3, and we're 4. All right, so here, look, perform and move to line of sight action. Well, we don't have move to line of sight action in here at all programmed, but the reason for this is because the radius, which is our, you'd have to draw a circle, right? Where the radius is 450, right? So how do we draw the circle? How do we draw the circle where the radius is 450? Let's do that last part. Maybe you get, if you want to help me out, or even Jaden. So I want to draw this last thing, and I want to only draw the radius in the I'm inside of the placing. So here's the draw function, and the draw function, if is my grid enabled, then I want to draw collision bounds. If my grid is enabled, I want to draw the draw circle. Let's do it together, right? So if it's true, now this is for each obstacle, but I want to draw the the thing around the circle around this. So I want to say util. I want to draw a circle, okay, but where is the center of the circle? The center of the circle is going to start at glm vec2, the m_p starship get transform, there it is, dot position, that's the center. And then it says the radius is the radius of the, we set the distance to 450. So that is going to be the radius. So that's the distance between, like, that's a big radius. That's huge, 450, right? And the color is green, red, green, blue. I'm okay with that. Okay. So there it is, draw a circle, green, and that's the radius. And it's going to change every frame. The position is going to, whatever the starship is, so too is that thing. Let's see if it's going to work, and if I'm not totally crazy. So again, I turn it on, and I toggle the grid on, and there's that radius. That's why it stopped. It stopped because it says it can't detect the player. We don't have line of sight, but the player is within radius. There's the line of sight. Line of sight is 400, but outside of the line of sight, that is radius, right? Okay. And one thing we didn't do is we didn't change the color of the radius to make it red or green. You can do that if it's outside the thing, but let me show you what this looks like when I move it. So if I move the target position down, you can see I'm out of radius, then it starts moving, right? So it'll keep moving until the ship is within radius. Let's put it way back up here again, just to give you a sense of that. So there's the ship. You can see that that's the radius. It's almost like it's in its radar, right? Can't see the ship. It's too far away. Maybe it has poor sensors. But as soon as this radius here comes closer, then you're going to see that as soon as it does that, it's going to stop moving, because now it's in patrol action, right? Take a look. And as soon as it turns, boom, it intersected this radius. The ship is within the radius. Now it's moved to line of sight action. Well, we don't have quite line of sight action. The next thing to do is keep moving until line of sight is true, right? Until this line here, line of sight is true. And I'm not going to do that. I want you guys to do some of that, but there's the radius. And if you wanted to make this radius smaller, let's suppose the line of sight distance is longer than the radius. Here, another way of doing it to test this out, but that kind of showed it. So we know our line of sight distance is 400. Let's say our radius is only 300. If we can't see someone, but if they're close by, then it's 300, right? So we can say, well, okay, so we'll make this 300. So that's the actual draw circle. And we can say that we can test to see is depending on if the uh, if the player is hit or not, right? If the starship get enemy hit node is true, right? If it's true, then sorry, if the player detected node is true, right? If this is true, then what we're going to do is get detected. If it's true, then we're going to say that it's green. Otherwise, it's red. Let's do that too. So we'll make that change, color change. So um, we'll say auto detected, just to make it in 2 lines, is equal to m underscore p starship, and then we'll what we want to do is get tree, get tree, and then we want to get player detected node, and then get detected, and then that is if I'm detected or not. So that's detected, and depending on if I'm detected, then if I'm good, if I'm detected, then the value is a GLM vec4, which is 0 RGB, right? Otherwise, we're going to say that it's red. GLM vec4 RGB. That's what it's going to be. Okay, so that can change the color of the radius so that it is red or green, depending on if I'm detected or not, right? And of course, what we want to do down here is change the radius. Instead of being 450, we can change to 300 as for testing purposes. So it's going to be smaller here and here. And that's going to determine the radius. Let's see if this works. And to give you more information about how this can work. Okay, so let's turn it on, and we can see that indeed this radius is within, even though it's small. You can see that the ship starts off within radius. If I move this thing down, now the ship is not within radius. Take a look, it turned red. Oh, but I do have line of sight there. I had line of sight there for a small bit. And then, okay, now take a look. Oh, I'm within radius, but I don't have line of sight. That's pretty cool. This is the radius condition right here. So you can see what happened here. Move to line of sight. And I can move them way over here. And you can see now it's not within line of sight and not within radius. And I'll patrol until one or both conditions come into play, right? So there we go. And it says move to line of sight action. We are within radius, but not within line of sight, you know, kind of stuff. If I move here's something funny. If I move the obstacle around, so this obstacle, this one obstacle, let's see if I can move this one around. Okay, now it says move to attack. So move to line of sight action, and it says attack action. I can see him because he's there. I can do it. And if I put it back, then it says move to line of sight. And you can see that that happens every single time if there's something blocking my view. So it's pretty good. And that kind of handles most of that stuff for you guys. I think we covered most of it. I just want to make sure here. So we added all those, modify the new build tree. It's going to take a long time. We did the placing. We did not have a chance to fire a torpedo. Maybe we'll do that next time when we're together. So we didn't have a chance to do that. But we did have a chance to pretty much do everything in terms of all the conditions and everything else. So I think that's where I want to leave it today in terms of the whole thing. Any questions from you guys before we go, we end for the day? So again, git add dots, git commit -m, and we'll say tested ranged combat enemy in placing, which we did a lot of little things, git push. Any questions? Again, I know this was a long one, and I really appreciate you guys sticking around. At least I have somebody for an audience. So I also have some people online, which are asking some interesting questions. But anyways, that's about it for me. And I will see you guys on Thursday. and we'll go with that next lesson. Good luck. Hopefully, if you have any questions, please let me know on Thursday, and I'll go over them with you. Otherwise, that's it, guys. Thank you so much.